Good morning, welcome, and thank you all for joining us today. The University of Toledo is proud to host today's virtual event with NASA Glenn Research Center to explore opportunities for engaging the university and industry community with ongoing NASA programs. I'm Dr. Adrienne King, and I'm the Associate Vice President for Marketing Communications here at the University of Toledo. It's also my pleasure to serve as the moderator for today's event. As guests are joining us, I want to share a few housekeeping notes about our virtual event. Attendee names are not visible to other attendees. They're only visible to the hosts and presenters. Therefore, you'll notice that you'll only see your name in the attendee list to the right. For today's question and answer segments, I ask that you submit your questions using the chat box, which will be monitored throughout the session. To access the chat feature, click on the chat icon at the bottom of your screen. The chat panel will appear to the bottom right. Please be sure to specify which panelist your question is addressed to. Additionally, if you would like to change the view on your screen, you can click in the upper right-hand corner of your screen to expand or reduce. Now, it's my honor to introduce a dear colleague, Dr. Karen Bjorkman, Toledo's Provost and Executive Vice President for Academic Affairs and Distinguished University Professor. A dedicated educator and scholar, Dr. Bjorkman is an astronomer and astrophysicist who became fascinated with science, and particularly astronomy, as a child watching the Apollo moon landings in real time on grainy black and white TV images. Dr. Bjorkman.
Thank you, Adrienne, and good morning, everyone. It's my pleasure to welcome you to today's event, Connecting NASA Space Technology through the Glenn Research Center, which is a joint effort of the College of Engineering at the University of Toledo and the NASA Glenn Research Center. As Adrienne said, my name is Dr. Karen Bjorkman, and I serve as Provost and Executive Vice President for Academic Affairs here at the university. I also offer greetings from Dr. Gregory Postal, our interim president, who was unable to be with us today. I am delighted to welcome all of our participants to this special event with this esteemed group of panelists. As an astrophysicist myself, NASA holds a special place in my heart because it inspired me as a young person, and it has been instrumental in supporting my own research programs throughout my career. The University of Toledo's engagement with the NASA Glenn Research Center is very special. We started offering engineering degrees at NASA Glenn over 50 years ago, and University of Toledo employees continue to work on site in Cleveland to support NASA's exciting science and engineering missions. I'd like to share a little bit of information about the University of Toledo. The University of Toledo is among a select number of universities nationwide that offer programs of study across a very wide spectrum of academic disciplines, including arts and humanities, the sciences, engineering, education, business, law, medicine, and many health professions, including nursing and pharmacy. Our faculty members produce research results that are reported in the top journals in their fields. And as provost, I've been particularly impressed with how our faculty translate their research into outcomes that are relevant for our region and for the state of Ohio. Today's workshop is designed to foster stronger connections between the university, industry, and businesses in Northern Ohio with the exciting programs at NASA Glenn. And we have a superb list of speakers joining us today, including Congresswoman Marcy Kaptur, NASA Administrator Jim Bridenstine, Dr. Marla Perez Davis, the director of the NASA Glenn Research Center and a University of Toledo alumna, and Jim Ryder, Associate Administrator for the Space Technology Mission Directorate. I know you'll be impressed with the ambitious plans underway at NASA as you learn about the many opportunities to connect with them. It's now my pleasure to introduce Dr. Marla Perez Davis. As Director of NASA Glenn, Dr. Perez Davis oversees 3,200 civil service and support contractor employees and has an annual budget of more than $900 million. She holds a bachelor's degree from the University of Puerto Rico, a Master of Science degree from the University of Toledo, and a doctoral degree in chemical engineering from Case Western Reserve University. Welcome, Dr. Perez Davis and all of our attendees. Thank you.
I know we're waiting for Dr. Perez Davis to join us.
Thank you, Dr. Brockman. Nice Welcome, I really appreciate it. Thank you for the opportunity to be part of this great event. And University of Toledo has been an extraordinary partner making this event, virtual event, a reality. So the first chart, please. Can I get the first chart? For more than 75 years, NASA Glenn Research Center in Cleveland, Ohio, has developed technologies that increase the performance and safety of air travel and improve system and capabilities for missions in deep space. With more than 3,300 civil servants and contractors, NASA Glenn represented one of the NASA 10 centers conducting research and technology development that make it possible for our nation to continue exploring, discovering, and innovating to shape the world of tomorrow. NASA Glenn has two main campuses, Lewis Field in Cleveland, Ohio, which houses the majority of our staff and facilities, and our Plumbrook Station in Sandusky, Ohio, about 45 minutes west of Cleveland, is home to some of the world's largest and most capable space simulation test facilities. Today, my staff is developing systems that will improve future space passenger aircraft efficiency and reduce fuel usage, emissions, and noise. We are doing this through more electric propulsion systems and stronger, lighter materials and components, while also advancing aerospace communication technologies that help improve our crowded skies. We are contributing to our nation's exploration of this space by developing in-space propulsion and surface power systems, testing flight hardware, and studying the effect of living in reduced gravity for long duration to help our human and robotic explorers on the moon before turning our sights to Mars. And Glenn plays a significant role in many of other projects that will help us accomplish NASA's goals and missions while providing numerous benefits here on Earth. Chart number 3, please. Can I get chart number 3? Well, we may not launch rockets at NASA Glenn. One before that. Can I have the chart before that one? Thank you. While we may not launch rocket at NASA Glenn, we have a proud history of contributing revolutionary, disruptive technologies to not only NASA, but commercial partners across the country. Our primary roles has been propulsion, power, and advanced materials and structure development. Glenn started as an aircraft engine research laboratory, so air-breathing propulsion is in our DNA. Today, we are bringing revolutionary concepts, technologies, and systems to market aim, which are significantly advancing the aviation. Our expertise lies in compressor and combustor research for high-efficiency propulsion systems, while also working to reduce energy consumption, aircraft noise, and emissions. We lead the agency in advanced power and propulsion systems, including hybrid electric propulsion system, where electricity generated from gas turbines or provided from onboard energy storage sources like batteries. In addition to air-breathing propulsion, we also lead the agency in the development of an in-space propulsion system, which includes propellants, chemical propulsion, electric propulsion, and nuclear propulsion. We are leading the development of solar electric propulsion for NASA, and our expertise has used to manage the development and build of the power and propulsion element for NASA Gateway in lunar orbit, which will be an orbiting platform for sustained lunar exploration and a staging point for future missions to Mars. It also involves the knowledge, capabilities, and practices associated with cryogenic fluid management, including cryogenic fluid hardening, characterization, storage, delivery, and flight demonstrations. Power energy storage is also another leading area for NASA Glenn, as we have essential expertise in solar power generation, batteries, fuel cells, regenerative fuel cells, radioisotope, fission, power electronic, and power management and distribution. Our team managed the radioisotope power system program, which power rovers like the Mars 2020 rover that just launched 2 weeks ago. And our fission surface power team is now developing mission concepts and performing additional risk reduction activities to prepare for a possible future flight demonstration. These surface power systems are essential to our extending exploration of the moon and long-duration stays on Mars. Our power expertise has traditionally been in space-oriented, but we are now bringing the knowledge into the aeronautics, specifically regarding hybrid electric and more electric commercial flight. Glenn researchers develop and applies advanced materials and structures for aerospace systems, which activities ranging from materials research at the nanoscale to developing and enabling technologies for high performance, long life, and lightweight systems for extreme environments. These efforts include the development of lightweight, high-performance alloys or shaped memory alloys for flight system and rubber tires, as you can see here in this picture. We are developing also cutting-edge technologies in the area of communication to improve air traffic management, communication and navigation upon satellites, air traffic, spacecraft, astronaut, and ground operations. We also play a leading role in physical science and biomedical technologies in space as we study the effects of long-duration missions on astronaut health to support long-term sustainable exploration of space. We are home to some of the world premier test facilities, including the world's longest running aircraft icing research tunnel, one of the world's quietest subsonic wind tunnels for acoustic testing, and the world's largest thermal vacuum chamber, and a truly unique facility called NEAT, where we can test full-scale powertrains for future electric aircraft. Next chart, please. So this chart really gets to the essence of our discussion today. It talks about the collaborations and the opportunities that NASA brings to the area, industry, academia, and other federal agencies. And we pride ourselves in solving the most difficult challenges that we can ever face. Throughout our history, NASA innovators have produced some of the most revolutionary technologies we have seen. And on average, our engineers and researchers create more than 1,000 new technologies every year, including some of revolutionary potential. But NASA doesn't bring these technologies to market. We need robust partnership to ensure our technology is available to companies to generate world benefit, everything from creating jobs to saving lives. Later today, you are going to learn more about some of the opportunities for partnerships and collaborations with NASA. We also have many partnerships and licenses with local, regional, and national organizations. We are committed to partnering with a wide variety of domestic and international partners to successfully accomplish our missions, including the Artemis program and Future Aeronautics Initiative. Our commercial licenses allow companies to make and sell products based on NASA technology. At the current time, we have about 230 active patents and maintain 29 active licenses. We also lead the agency in executing licenses. Using this partnership mechanism and others, we develop strategic opportunities around mutual objectives and focus our ways to ensure NASA technology benefits the US economy. Next chart, please. NASA has joined the fight against coronavirus with efforts underway across the country to augment the national crisis response. At NASA, Glenn is at the forefront with two partnerships that are actively working to help the nation recovery. In 2015, amid concerns about Ebola virus, NASA Glenn partnered with Kent-based Emergency Products and Research, or EP+R, by helping the company develop a fast and portable decontamination. Several expensive sterilization systems were already on the market for hospital operating rooms, but running those systems took hours, and first responders and small hospitals don't have the kind of money or time. So with our help, EPR+R developed a portable machine that sprayed a mist of the contamination solution. The machine is called Ambustat, and it decontaminates spaces such as ambulance in under an hour and a fraction of the cost for other systems. Today, we are working with them to develop or conduct research and testing on the next generation, called Ambustat G2, to combat COVID-19 in hospitals, ambulances, police cars, schools, and other public spaces. The G2 model can be used to sterilize surfaces and to attack small viral particles that float in the air, like the novel coronavirus. We have been testing a prototype in our labs to help them understand the droplet size and how it disperses in large spaces like classroom or crack or crevices like you have in a police car. We are also helping them minimize the cost by finding the minimal amount of solution that is needed to produce the desired result. We also have another activity. This one is a partnership with the University Hospital in Cleveland to develop new methods for the contamination personal protective equipment, PPE, for aerospace application and for safeguarding the health of workers caring for patients with coronavirus. Glenn engineers developed a process and hardware to decontaminate masks using atomic oxygen. Present in low Earth orbit, these single oxygen atoms can remove organic materials that cannot be easily cleaned by other methods. We can create atomic oxygen on Earth by putting ozone in the chamber and heating it. As the ozone decomposes into atomic oxygen, it can kill organisms like viruses. Further testing is needed to verify the method that can be used to perform multiple decontamination cycles without damaging the mask. NASA provided a prototype to UH to test on the N95 mask. Early results confirm the method deactivates the virus, and continued testing will determine the minimum ozone concentration and exposure time needed for disinfectation. The process could be scaled up to treat multiple batches of PPE or made portable units for small hospitals in rural areas. I would now like to introduce a great friend to NASA Glenn and a huge supporter of the aerospace community, Representative Marcy Kaptur. Congresswoman Kaptur is a native Toledo, and she is currently the longest serving woman in the history of the U.S. House of Representatives and ranks among the most senior members of the 116th Congress. Prior to being selected to Congress, Representative Kaptur spent 15 years as the city and regional planner in Toledo and Chicago, before accepting a role as a domestic policy advisor to President Jimmy Carter. She was elected in 1981 and won a seat on the House Appropriations Committee. Today, she is the first woman to chair the House Appropriations Subcommittee on Energy and Water Development, which is especially important given her district spans much of the Lake Erie coastline. And she is a senior member of the House Appropriations Subcommittees on Defense and Commerce, Justice and Science. And before I turn the microphone over, I wanted to quickly point out that the picture on the screen is for Representative Kaptur's visit to Plum Brook Station in March to celebrate the completion of the testing for the Orion spacecraft for the Artemis 1 mission. This was an important milestone for the agency, as Artemis 1 is the first of several missions that will lead to the first woman and the next man stepping on the moon in 2024. And we were proud to share in that accomplishment with her. Please welcome Representative Marcy Kaptur.
Congresswoman Kaptur is going to be calling in this morning. So if I could have Congresswoman Kaptur say test. I know we've got quite a few folks who have called in. We've got to figure out which line Congresswoman Kaptur is on. So if you could please continue to say test until we're able to identify you and unmute you here. Congresswoman, I think we've found you. You are all set. Thank you so much for joining us this morning.
Thank you very much. And Director Dr. Perez Davis, thank you, Dr. Bjorkman and Dr. King, and thank you to the University of Toledo and the NASA Glenn Research Center for convening our conversation today toward building better links to Toledo. Our discussion will focus on NASA's ongoing projects, opportunities, and plans for the future, and I'm so proud of the NASA team at Brook Park. Our nation and world are entering a new era. We're making our way to Mars, creating sustainable air transportation, and returning to the moon after almost half a century. Ohio is a leader in several areas critical to the Artemis moon mission, including the Gateway's power propulsion element, cryofluid management, lunar surface power, and in-situ resource management. We live in an era of exploration, wonder, discovery, innovation, creation, achieving what could only be dreamt of a decade ago. This has led to rare, bipartisan funding and support of NASA's mission. NASA's Small Business Innovation Research and Technology Transfer Program received 409 technology proposals for the first phase of funding. The contracts will provide approximately $51 million to 312 small businesses in 44 locations. More than 100 of the selected companies will be first-time recipients of a NASA SBIR or STTR contract, and 27% of the small businesses are from underrepresented groups. That is phenomenal. For universities, NASA offers initiatives such as the Space Technology Research, the Lunar Power Centennial Challenge, and internships for students at all different levels. We will hear more about all of these great programs and opportunities throughout the day. We have much to celebrate here in the home state of John Glenn and Neil Armstrong. Without question, Ohio is a shining example in the aerospace industry and all of the firms that make this happen in partnership with NASA. Just a few short miles east of Toledo, near Sandusky at Plum Brook Station that Dr. Perez Davis referenced, Ohio boasts one of America's best-kept secrets. Plum Brook Station is home to cutting-edge testing capabilities for America's space mission, in addition to its test bed for the next generation of electric aircraft. Then, at the Glenn Research Center near Cleveland, we have one of the smallest but most diverse NASA centers. Glenn leads the world in solar electric propulsion. That's a big wow for me. It is protecting the Earth from asteroids. It is developing nuclear power systems for space and developing aerospace technologies that will revolutionize air travel. Ohio, the state of flight, has it all. We are writing the next chapter in American history. Glenn Research Center is able to turn an annual budget of $928 million into a $1.7 billion impact on Ohio's economy, thanks to the over 7,000 jobs related to Glenn and Plum Brook. I can say without hesitation that Glenn Research Center and Plum Brook stations are leading American advances in aerospace and space exploration. Now, we have to think harder about how to make NASA matter locally. Glenn continues to push the boundaries of human ingenuity. For our companies to compete and to win contracts managed by Glenn, we must do a better job of linking to NASA's regional economic development program. Glenn can serve as a facilitator for regional partners in technology transfer. In the last 5 years, the University of Toledo has been awarded about $25 million total from NASA, with $14 million coming from NASA Glenn Research Center. The University of Toledo received 33% of the entire pie of research that Glenn awarded in the state of Ohio. That is amazing. We should be proud of these important grants. We received funding for important projects like Dr. Theo Keith's work on advanced material research to help create high-temperature and lightweight material. Dr. Kevin Paul Chakowski's work on the Mission Earth team, which brings together scientists and science educators to create a K-12 Earth science curriculum. And Dr. J.B. Smith's work to look into the past of our cosmic calendar. Glenn and Plum Brook receive about $850 million for projects that run the literal gambit across NASA's missions. However, as a region, we simply must do better of capitalizing on NASA's programs to keep this expertise at home. Of NASA's $22.5 billion overall budget in the country, Ohio receives about 3%, 3.7%, about $850 million, as I've referenced. Of that money, many of the large contracts are awarded to out-of-state companies and managed by research centers in other regions. This is an important horizon for us to challenge. Now, in talking about our piece of NASA's assets, annual assets, NASA's budget for early-stage innovation partnerships, we've referenced the SBIR, STTR, and technology demonstration, is enormous at about $1 billion. As a region, we must capitalize on these national programs and ensure our economy and region can benefit. Don't get me wrong, we should be proud that the University of Toledo received $25 million from NASA in the last 5 years. But surely we can do better. Today, we can put the pieces together to better utilize the various range of NASA programs. We have to get to know the names. SBIR, Innovation, STTR, Technology, the RED, the STEM, and Partnership programs represent an enormous opportunity locally. Today, you will hear from leaders at NASA that can break down these partnership opportunities and give you a chance to compete. I challenge each and every one of you to identify a new program and then apply. You have in your hands the opportunity to build a brighter future for our region by literally tethering your expertise to NASA and build links to the future and help to develop skills in the next generation. From UT's co-op program to your cutting-edge expertise in solar cell technology, to chemistry and advanced shape alloy design and materials research, our region has the expertise to keep our nation at the cutting edge. In closing, let's say we're going from an idea to a plan, to a lab, to NASA, and then to Moon, to Mars, and beyond. Today, there is no limit to what we can achieve, and there is no more exciting time in history than this one. Before I close, let me give a heartfelt thanks to my former House colleague and current NASA Administrator, Jim Bridenstine. He has done a phenomenal job. I greatly appreciate everyone who's on the call in today for your willingness to participate in this event. We know that with your leadership, headquarters will continue to grow the collaborations with key partners in Ohio. We very much value and appreciate your hard work and recognition of Ohio's heritage of innovation, exploration, and flight. Thank you so very much, Administrator Bridenstine, your staff, and the hundreds of registered participants for today's forum.
A special thanks to Congresswoman Capter for joining us today. Thank you for all you do for the state of Ohio, and especially for all of the support that you continue to provide to the University of Toledo. We are very appreciative that you were able to find time to join us. Next up, I'd like to introduce Mr. Jim Bridenstine, NASA's 13th administrator nominated by President Donald Trump and confirmed by the U.S. Senate in 2018. Under his leadership, NASA has launched its new human lunar exploration mission, the Artemis program. The program is expected to land the first woman and the next man on the surface of the moon by 2024. The first human landing since the end of NASA's Apollo missions in 1972. Through the program, NASA is developing the Orion Crew Capsule and Space Launch System, the most powerful rocket ever built. Jim has managed the continued commercial resupply of the International Space Station and has led agency efforts to partner with American businesses on the Commercial Crew Program. Also under his leadership, the agency has reinforced aeronautic development of the X-59, a quiet supersonic aircraft, and the X-57, the agency's first all-electric airplane. He also backed NASA's aeronautical innovators to develop the unmanned aircraft systems traffic management to facilitate the safe use of drones for commercial enterprise and in everyday life. The agency's dynamic science portfolio includes a life-seeking Mars Perseverance rover that launched July 30th, 2020. I'm sure many of you, if not all of us, tuned in to watch this exciting launch. I know my family has been really enjoying tracking its progress online. We're honored to have him here with us today to give the keynote address. Jim, I'll turn it over to you.
Well, thank you so much, Dr. King. It's an honor to be here with the folks of Toledo, the University of Toledo, and of course, I want to give a special thanks to Congresswoman Marcy Kaptur, whom I served with in the House of Representatives, and I will tell you, she's a great leader. She is somebody who cares deeply about the region. And of course, as you heard today, she works very well with members of colleagues on both sides of the aisle to support the NASA Glenn Research Center and Plumbrook Station. And I just want to thank her for all of her leadership. Without her support, NASA wouldn't be where it is today. And we're doing really amazing things. As you mentioned, Dr. King, I also, before I get started, I want to give a shout out also to Dr. Marla Perez Davis, the center director there at the Glenn Research Center, who's been doing just a wonderful job keeping the trains running on time. So thank you to Dr. Marla Perez Davis as well. So a lot of you saw, and Dr. King just mentioned it, recently we launched American astronauts on American rockets from American soil for the first time since the retirement of the space shuttles back in 2011. And that was a great moment, but it was unlike any previous human launch before in the sense that NASA did not purchase, own, and operate the vehicles. NASA was a customer. Make no mistake, we invested billions of dollars, and of course our scientists and engineers were embedded in the mission all the way through, start to finish. But it's also true that our goal was not to own and operate the vehicles. Our goal was to create a robust commercial marketplace. So the first thing that we started a number of years ago was commercial resupply. We now resupply the International Space Station commercially. We buy a service to take goods to the International Space Station and science experiments and technology developments. And now we're doing it with crew for the first time. We're buying a service to take crew to the International Space Station, and eventually we're going to have commercial space stations themselves. We're commercializing low Earth orbit. And of course, a lot of the research that's being done at the Glenn Research Center as it relates to fluid management and air flows and the way things burn in microgravity, even the way things burn is very different in microgravity. All of these things are going to conspire to create this very robust commercial marketplace in low Earth orbit for human spaceflight. Make no mistake, space is already a $400 billion economy. But what we want to see is we want to see human activity in space. We want to push humanity deeper into the solar system, and that requires commercial partnerships. And of course, when we think about commercial partnerships, already we partner, the Glenn Research Center, they're in Cleveland, partners with the University of Toledo. Right now, I think there's a number of grants. I think there's 5 grants with the University of Toledo right now that constitute about $8 million annually. And then we also have other cooperative agreements, and we have purchase orders for another $8 million, a total of $16 million of business every year already with the University of Toledo. As Representative Capter said, though, we can do better. We want these partnerships to grow. We want to inspire not just the universities, but small businesses. Dr. Marla Perez Davis talked about AmbuStat, which of course is a tool that was developed there. It takes capability from resources that were developed at the Glenn Research Center. What does that mean? When we send a spacecraft into space, when we land a robot on another world like Mars, some of you saw that we just launched the Perseverance rover to Mars. We have to sterilize that spacecraft because we don't want to accidentally plant a probe on another world. We don't want to plant, I say a microbe. We don't want to plant a living organism on another world and then later make a discovery and believe that we found life on another world when in fact it was life from the Earth to begin with. So we have to sterilize these vehicles, and when we sterilize these vehicles, we use a chemical composition and a fog, and ultimately that's the capability that has resulted in AmbuStat, which is now being used across the nation to sterilize ambulances. It's a fogger, and it'll sterilize ambulances, police cars, classrooms to keep people safe, hospitals, and it sterilizes every surface within within these compartments. So the idea is NASA technology has applications that go well beyond space exploration. And of course, that's very well known, the way we communicate, DirecTV, Dish Network, internet broadband from space, XM radio, a lot of remote sensing capabilities, GPS technology, the way we navigate, the way we produce food and energy, the way we do banking requires, you know, a signal from the GPS constellation for timing. So all of these technologies have improved human lives on Earth, and all of these technologies were born from this little agency that we call NASA. But a lot of it is accelerated, and it is commercialized in a way to benefit human lives. When the technology moves away from NASA and into the commercial sector, and NASA has a keen interest in partnering with universities and then commercializing those capabilities to the benefit of all humanity. When we think about low Earth orbit, I mentioned we're commercializing the resupply of the International Space Station, which has been done. Now we're commercializing crew to the International Space Station, which has now been done once. We're going through all the data reviews of the vehicle, and we'll be flying more routinely here in the very near future. And then we want to commercialize space stations themselves. And to commercialize space stations themselves, we're looking at two main focuses, foci, whatever it is. We're looking at a couple of things. Number one is industrialized biomedicine. When we think about industrialized biomedicine, how do we compound pharmaceuticals or create immunizations using the resource that is the microgravity of space? That's what we're trying to do. There is tremendous value there for medicine and industrialized biomedicine. We've created vaccines for salmonella, for example. I should say we have advanced vaccines to make them better and more efficacious vaccines for salmonella, which in the United States of America is not that big of a deal. But in other countries around the world, it's the third leading cause of death among infants. So if we can vaccinate people against salmonella, when we think about a vaccine for pneumonia, which has been vastly improved because of research done in microgravity on the International Space Station. We're proving right now on the International Space Station that we can actually create human tissue using adult stem cells, in fact, skin cells. So we can create tissue that perfectly matches your body using your adult stem cells, which right now it's tissue, but it can be grown in 3 dimensions in space because of the microgravity. If we tried to do that here on Earth, it would just go flat and it wouldn't be effective at the treatments that we're seeking. So we think about those kind of activities that are going to be transformational for life on Earth. We're creating artificial retinas in space, something you can't do in the gravity well of Earth because the material is so thin. We're talking about 1 or 2 atoms thin. And we can create those kind of materials in the microgravity of space, but we cannot do it in the gravity of Earth. So if we can create artificial retinas, we can prevent people from going blind who have macular degeneration, for example. So these are all ways to do industrialized biomedicine. We also have another line of effort, advanced materials, things like fiber optic cables that can be created very pristinely in microgravity. You know, on the Earth, they're not as clean, and therefore you have to have cable repeaters. So if we can commercialize low Earth orbit, which is what we're working for every day, and we're looking to the private sector and academia to help us maneuver to commercialize low Earth orbit, then we can do the things for which there is not yet a commercial marketplace. And the big thing right now is going to the moon under the Artemis program. You know, Dr. Marla Perez Davis talked about sending the next woman and the first man to the moon by the year 2024. We're working towards that every day. And what happens at the Glenn Research Center is critically important for that mission. I'll give you an example. You saw the picture there with Representative Marcy Kaptur in front of the Orion crew capsule. That was at Plumbrook Station. And when she was there, that vehicle had been tested. It came through testing with flying colors. But now we know that it is certified for space flight with humans, and it is ready to go to space. Now we just need to get that big rocket, the SLS rocket, built. In fact, it is. The core stage is ready to go. It's built. We just need to test it, and we're going to be testing it down in Mississippi in the coming months. But eventually, we're going to send that Orion crew capsule all the way to the moon with humans. And of course, it'll be not just the next man, but the first woman under the Artemis program. Now, we call the program Artemis for a lot of reasons. We think about Greek mythology. There's Apollo in Greek mythology, and we love the Apollo program of the 1960s and early 1970s. But in the Apollo era, all of our astronauts that walked on the moon, all except one, they all came from fighter pilot backgrounds or test pilot backgrounds. And in those days, there were no opportunities for women. Well, in Greek mythology, it just so happens that Apollo has a twin sister, and her name is Artemis, and she was the goddess of the moon. This time when we go to the moon, we get to go to the moon with all of America, including women, and we go under the name of Apollo's twin sister, Artemis, who was the goddess of the moon. I think it's a really great story about how far America has come, and yet how much further we still have to go. But we think about Artemis, and we think about the Glenn Research Center. It's not just that Orion crew capsule that, of course, was tested at Glenn Plumbrook, but it's also about something we call the Gateway. The Gateway is a space station that will be in orbit around the moon for a design life of 15 years. Think of it as a reusable command module in orbit around the moon. In Apollo, we only went to the equatorial regions of the moon. Now, when we go to the moon, we get to go to every part of the moon. We're going to have access to the North Pole and the South Pole, the equatorial regions. And the reason we need to get to the North and the South Pole is because that's where the hundreds of millions of tons of water ice is. You heard Dr. Marla Perez Davis talk, or I think it was actually Representative Marcy Kaptur who talked about in situ resource utilization. How do we use the resources of the moon to live and work for long periods of time? Water ice is H2O. Oxygen, of course, is air to breathe. It's H2O is water to drink, so it's life support. And the hydrogen is, in fact, rocket fuel. And it's available in hundreds of millions of tons on the South Pole of the moon. So in order to get to the South Pole, we need to be able to maneuver around the moon in ways that we've not been able to maneuver before. And for that, we have a project called Gateway. The first element of Gateway is the power and propulsion element, which of course uses technologies that have been born and developed there at the Glenn Research Center. That power and propulsion element uses solar electric propulsion. We call them Hall thrusters. But think of the fuel is xenon, but think of subatomic charged particles being ejected out the back of a vehicle and using that as propulsion. And it's all powered by the sun, which of course is another amazing capability. Now we're scaling it up. The power and propulsion for the Gateway, which is a maneuverable space station around the moon, that power and propulsion element has been advanced. And of course, now it's being developed and built by the researchers there at the Glenn Research Center and the contracts that they lead with commercial industry. So another amazing capability that comes from the Glenn Research Center. People already talked about aeronautics and the electrification of aircraft, which of course is going to be huge in the future. Glenn Research Center is very involved in those activities as well. So there's really a bright future. We're going to the moon. We're going sustainably. We're going to go with commercial partners and international partners. And ultimately, we're going with a purpose. And that purpose is to learn how to live and work on another world for long periods of time. And then we're going to take all of that knowledge and we're going to go to Mars. That's the ultimate objective. We need humanity to get to Mars. And we're working on that every day. We go to the moon as the proving ground. Mars is the destination. And so that's really what is on NASA's agenda right now. Another area, before I open it up to a few questions, another area where NASA is very involved, or I should say the Glenn Research Center is very involved, and Representative Capter talked about this as well, is power systems. You know, we have a nuclear fission capability for the moon that we call kilopower, which of course is going to provide, it's small, but it provides enough power to maybe do some in situ resource utilization, taking that energy and then using it to first of all get the water ice, separate it from the regolith, and then crack the H2O into hydrogen and oxygen. That's going to require power. Kilopower provides that capability. But the power on the surface of the moon is not the only thing that Glenn does. It's also power for the gateway, which of course is solar electric power and propulsion. So some really amazing things happening there at Glenn. And we're very grateful for the partnership with our commercial partners. We're extremely grateful for the partnership with the University of Toledo, the Rockets, and we look forward to a very, very bright future in these areas. So with that, Dr. King, I'm happy to answer a few questions or hear a few comments.
Fantastic. Yeah, that was very exciting. We do have quite a few questions coming in. As a reminder to our attendees, if you have a question for any of our panelists, please make sure that you're putting that in the chat. Jim, we're going to start with this first question about SLS. Why have there been delays in the launch for the SLS?
So when NASA builds things, generally what we build are things that have never been built before. And we have to invent things that go onto our new capabilities and our new technologies. And when it comes to doing these kind of development projects, we learn things along the way that we didn't know before. So NASA, for example, I'll just give you one example. Doing friction stir welding, and of course this was before my time at NASA, but it's I think it exemplifies the challenge. Doing friction stir welding with material that is that thick and pieces that are that big, it's never been done before. And it took NASA a lot of time to figure out how to do that. And we developed the capability to create these massive hydrogen tanks and these massive oxygen tanks. Remember, this is the most powerful rocket that's ever been built. It's going to take our astronauts to the moon. And so these kind of things take time, and we have to invent things. In this case, we had to invent the tooling that would enable us to build the components. The tooling being the friction stir welding machinery. That being said, once that's developed, the great thing about NASA is that we don't keep it to ourselves. We share it. We share it with our commercial partners. They can then buy it off the shelf. They don't have to spend the hundreds of millions or even billions of dollars developing the capability. We make it available to them, and then all of a sudden they can move quickly and they can scale quickly. And so companies, rocket companies in the United States, across the country, have taken what we have developed and they're applying it to their own capabilities. I do hear sometimes, and it's frustrating sometimes, oh, look at how good the commercial sector is compared to NASA as it relates to SLS. Make no mistake, the commercial, like I said, we are moving rapidly to commercialize low Earth orbit. And when we go to the moon, we're thinking commercially as well. The landing systems that go to the moon, the human landing systems, are going to be commercially owned and operated. NASA is not going to own and operate them. That being said, a lot of these commercial capabilities are a direct result of the trial and error and investment that government was willing to make that commercial companies won't make because the risk is too high. And that's where the partnership between public and private is so important. We can take risks that a company that's worried about their quarterly earnings statement cannot make. But we can make those risks. And because we're willing to do that, we can move ahead, and then they can move ahead with us.
Great. Thank you so much, Jem. You mentioned earlier that the moon was just the first step. The ultimate objective is Mars. So we've got a question here. Can you provide additional insight into the why behind Mars being the end destination? What is ultimately driving the steps from the moon to Mars? And how are we creating an infrastructure to enable a thriving, sustainable space ecosystem?
Oh, that's an amazing question. That's an hour in itself. In fact, that wouldn't be enough. But I'll kind of put it in a nutshell. So in the last couple of years, we've made some amazing discoveries on Mars. Mars is covered in complex organic compounds. The building blocks for life are all over Mars. They don't exist on the moon at all. They're all over the Earth and they're all over Mars. Does that mean that there is or that there was life on Mars? We don't know, but the probability certainly just went up significantly. We have found now that the methane cycles of Mars match the seasons of Mars, which increases the probability that maybe there could be life under the surface of Mars. I'm not saying there is, I don't know. And then the other thing is we're seeing massive plumes now of methane coming out of Mars that some people say it could be geological in nature, but the probability of it being geological has gone down, which means the probability of it being biological has gone up. Again, I don't know that there's life there. As the NASA administrator, I have to be very careful. But it's also true that we have now found what we believe to be liquid water 12 kilometers under the surface of Mars. Now, what do we know about liquid water on Earth? Wherever it is, there's life. Is that true on Mars? Again, we don't know, but I'm telling you, now is the time to go make these discoveries. I will also say and of course we know these things from Curiosity, and now we're sending Perseverance to the Jezero crater. Curiosity, of course, is at Gale crater. We're looking for these areas where there's the highest probability that there was ancient life on Mars. And of course, if you look at Spirit and Opportunity, our two rovers before that, they made discoveries that Mars was at one time covered. The northern hemisphere of Mars was 2/3 covered in water. Mars had a thick atmosphere that protected it from the radiation of the sun and the radiation of deep space. And Mars had a magnetosphere that protected it from, not just an atmosphere, but a magnetosphere that also protected it from the radiation of space. And a thick atmosphere that was capable of hosting life. Not that it did, but it was capable. All of these things conspire to say, we know the history of Mars. We're learning a lot about the present of Mars. And for the first time not Perseverance. Yeah, Perseverance. For the first time, we're doing an astrobiology mission. Like, we're going specifically to find out if there's life on Mars, and we're going to cache some samples. We're going to bring them home. We're going to fly a helicopter on another world as a technology demonstrator. Listen, if we can fly a helicopter on Mars, that's going to open up how we do research for all of these other planetary bodies, whether it's Europa, a moon of Jupiter, or Enceladus, or Titan. There's all these different opportunities now to go to different worlds and get more science and discovery from these other worlds than ever before. So I think there's a lot of reasons to go to Mars for the scientific value. When we think about the moon, it's a little more strategic in nature, in the sense that if we're looking for data and information of the early solar system, there is no better place to go than the moon. And that's because the Earth has an active atmosphere and hydrosphere, magnetosphere. So all of the subatomic charged particles coming from the sun go around the Earth, but they impact the moon because the moon doesn't have any of that. They either go around the Earth, or if they hit the Earth, they're not today where they were billions of years ago. The moon, anything that impacted the moon billions of years ago is today right where it was billions of years ago. So it's a repository of data and information from the early sun, from the early solar system, and from the far side of the moon, where it's extremely quiet from an electromagnetic spectrum perspective. We're going to be able to see not just into not just the first light in the universe after the Big Bang, but we're going to actually see the Dark Ages, which was the period of time after the Big Bang and before first light. We're going to be able to see that and understand so much more. It's going to transform physics. And the United States of America has a goal to lead a coalition of nations to go to the moon sustainably, to do this kind of science. And that kind of science is made all the easier when we have humans on and around the moon. So it's about resource utilization. It's about science, heliophysics, the study of the sun, astrophysics, the study of deep space, planetary science, the study of our own solar system. All of that is available on the moon. And on top of it all, we think about the value of the moon. You know, on Earth, we call them rare earth metals, platinum group metals, which are really asteroid impacts from billions of years ago. Well, the reality is very few asteroids actually make it to the Earth. And when they make it to the Earth, the hydrosphere and the geology of the Earth, plate tectonics, all the movement of the Earth, they aren't today where they were, and they're very close when you find them. We could actually find trillions of dollars of large deposits of platinum group metals on the moon. I'm not saying we're going to find that, but if you just do the math and look at the probabilities, there's a good chance that we could find some significant discoveries. So the key is we need to go to the moon sustainably. You know, we need to be able to live and work. That's why kilopower there at Glenn is so important. It's why the gateway is so important. It gives us sustainability at the moon. And then ultimately, we need to take all of those capabilities and create an architecture that can be replicated at Mars. So that architecture, you know, a gateway is going to be critically important. The ascent modules, the ascent vehicles from the moon back to the gateway, we want those to be reusable, the landers to be reusable. In Apollo, as much as we love Apollo, the problem with Apollo is that it ended. We don't want the Artemis program to end. We have a directive to make it sustainable. And that directive from the president has bipartisan support in the House and the Senate. And Representative Kaptur talked about this. For the first time now since 1972, for the first time, we actually have a human landing system funded. Presidents in the past have talked about it. Nobody has delivered the budgets necessary to achieve it. But the president gave us a budget request, Congress with bipartisan support, and I want to be clear, Representative Kaptur is a big part of this, supported this program to ultimately enable us to go sustainably to the moon. So we need to take those elements of the moon program, and then as we create them, make sure that they are as much as possible replicable at Mars. And that's the ultimate objective. Sorry, long answer.
Jim, we're loving your passion here. I want to be respectful about your time. We do have a lot of great questions coming in. Do you have time for one or two more?
You bet. I'll answer shorter in the next one.
Okay. Well, this next question comes from one of our students. Is NASA working with quantum computers? And if so, what kind of research opportunities are available for students?
Another very important question. So quantum computing, of course, is the way of the future. NASA does have a good bit of research in that area. It's generally done out at the Ames Research Center, which is in Mountain View, California, south of San Francisco. The Ames Research Center, you know, we call it Silicon Valley. It's NASA in Silicon Valley, if you will. So we have a lot of research going on there regarding quantum computing. I will also tell you, you know, a key capability for NASA is quantum communications. Now, the reason that's so important is as we press further into the solar system, people are probably asking, maybe some people don't know what quantum communications are, but think of two electrons that are separated from their atoms, two electrons. You can pair them together and they become what is called entangled, quantum entanglement. You take those electrons and you separate them from each other. And if you spin one to the left, the other one spins to the right automatically. There's no communications between the two. It happens instantaneously and automatically. They are entangled. Even more fascinating, if you take those two electrons and you put one in California and one in Florida, and you spin the one in California to the left, and the one in Florida will automatically spin to the right instantaneously without any time delay. There is no signal between the two electrons. It's just absolutely fascinating. Einstein called it spooky. Even more fascinating, if you take those two electrons and you put one on one side of the solar system and the other on the other side of the solar system, and you spin one to the left, the other one instantaneously will spin to the right. Without any time delay, there is no signal between the two electrons. If you put one on one side of the galaxy and the other on the other side of the galaxy, the same effect happens. In other words, it is instantaneous communication capability with no signal required whatsoever, which means it's not jammable, it's not hackable, it's not spoofable, and this could, in fact, change the balance of power on Earth. China has already done a quantum communication demonstration from space with a partner, in this case, Italy. And we have to make sure, for the strategic interest of this country, that we lead in that area. Now, NASA doesn't do national security and defense. The question is, why does NASA care about quantum communications? Well, because if we're going to send, when we send humans to Mars, there's a 9-minute delay just to communicate. You talk into a radio. 9 minutes later, your voice will be heard, in mission control at the Johnson Space Center, for example. Well, if we're going to press even further beyond Mars, let's say we want to do a mission to Pluto. Now we're talking about a signal that takes 9 hours, not 9 minutes. And that's just not going to be satisfactory. We have to be able to communicate instantaneously. And if we can do that, we can actually do robotics, not autonomously, but we can actually remotely control robotics and those kind of things on other worlds that are a lot further away and give us more opportunity to get better and more science. So whether we're sending humans or sending robots and doing remote control, quantum communications is important. Quantum computing is also important, to make no mistake. But these are technologies that will change the balance of power on Earth, and the United States of America has to be at the leading edge of these capabilities.
Sounds like some great advice for our students who are tuning in to definitely look into these fields. Okay, we've got another question going back to Mars. How does NASA expect to combat the very thin atmosphere and the high carbon dioxide makeup that comes with it to make it habitable for humans?
Well, that's another great question. So when we think about the Perseverance rover that we just launched to Mars, that rover has an experiment on it called MOXIE. And MOXIE is going to take the carbon dioxide atmosphere of Mars and turn it into pure oxygen. And we're proving that we can do that so that when we do send humans one day, and we will, make no mistake, there will be an opportunity to have life support capabilities that are in situ. Congresswoman Capter mentioned in situ resource utilization. That's what we have to achieve. We have to use the resources of these other worlds to make it habitable for the human system. So the challenge is turning carbon dioxide into oxygen. We believe we can do that. We're going to prove that we can do that on another world. And then the other big challenge, it is a very thin atmosphere, and that makes it difficult to do the entry, descent, and landing. If you look at how Perseverance is landing, and if you look at how Curiosity landed on Mars, it starts off with a heat shield. The heat shield is used to dissipate a good bit of energy. But then once the heat shield is complete, or we've used as much of it as we can, it will deploy parachutes, supersonic parachutes that continue to slow the vehicle down. Ultimately, those parachutes don't slow it enough. You can't do a soft landing with those parachutes. So then we have rocket propulsion that does a retro burn. In other words, it slows the vehicle down even more and then puts it in a position to where it's actually stable over the surface of Mars. And from there, we use a sky crane. So as the vehicle is hovering over the surface of Mars, it lowers down basically a crane that lowers the robot onto the surface, and then the system flies off and crashes. But at the end of the day, we can get a robot to the surface of Mars. So that's one type of landing system that is proven to be effective. For humans, we're going to need a lot more impressive capability on the heat shield, especially because we'll need a lot bigger systems, and those bigger systems are going to require a much bigger heat shield. And of course, the complexity of a heat shield goes up by it's not linear; it's exponential. The bigger it gets, the more difficult it becomes when you have an atmosphere that's that thin. So I'll tell you, our scientists and engineers are working on it every day. it's doable. I want to be really clear. It is, in fact, it's doable. The risk is not technical. The risk is political, because we're gonna need the resources to achieve those things.
Well, Jim, you have talked about some amazing things that NASA is working on, and we're going to end with one last question. We know that in order to make these awesome things happen, it all starts with great leadership. So what is one of your greatest personal achievements as administrator?
Oh my goodness. Well, it hasn't been realized yet, but it was my first initiative as the NASA administrator, and it came with support from the Science Mission Directorate. The associate administrator there is Thomas Zerbukin. But one of my first initiatives is the CLIPS program, Commercial Lunar Payload Services. So we want to take small payloads for scientific purposes that NASA needs to get delivered to the moon. We want to take those to the moon commercially. Not human landing systems, but if you have a 15-pound, maybe a spectrometer, so that we can do the chemical composition of the regolith in certain parts of the moon, for example, we can get there commercially. So we would just buy a service, and then the landers would take our instruments to the surface of the moon. What we've done so far, we now have 15 companies that have been contracted to provide that service. The first 2 are scheduled to go next year, as a matter of fact. So in the year 2021, we could very well be landing on the surface of the moon commercially. NASA's not owning and operating the vehicle. We're going to own and operate the scientific experiment, but we're going to certainly contract with a commercial company to provide the capability to get to the moon. So that's one. The other thing that I think is very exciting, and again, it was under development before I got here, but it's something that I forced to happen, and that is the Mars helicopter. When I first heard about the helicopter, it was not planned to be on the Perseverance rover. And when I learned about it, I was like, we have got to make that helicopter fit on there. And it created a little turmoil at first. People were not happy because they'd been working on the Perseverance launch for a long time, and the Perseverance rover. But look, NASA figures things out. And I said, if anybody can do this, NASA can do this. We need to make this happen. And that helicopter, should it be successful, which I think it will be, it's going to transform how we do exploration on other worlds. Remember, the atmosphere of Mars is 1/100th the thickness of the atmosphere of the Earth. It's a very thin atmosphere. So the idea that you could fly a helicopter on that world, if we can prove that out, it's going to open up all kinds of different opportunities on other planets and moons of other planets.
Well, Jim, thank you so much for sharing so many exciting things. We've got lots to look forward to. We really appreciate the wonderful discussion. Thank you for joining us today.
Absolutely. Thank you, guys.
All right, next up, we have Mr. Jim Ryder, NASA's Associate Administrator for the Space Technology Mission Dictoriate. In his role, he provides executive leadership and management of the technology programs within STMD, with an annual value of $1.1 billion. He has a long, esteemed career with NASA, serving in a number of senior executive and managerial roles. He has earned a number of NASA awards, including recognition for distinguished service, outstanding leadership, exceptional service, and many more. Please welcome me and welcoming Jim.
Well, thank you, Adrian. It's a pleasure to be here today, and it's just a joy and a challenge to follow Jim Bridenstine. He's a great leader for us, and we're really excited where we are. I can't tell you how excited I am to be able to lead our space tech organization for the agency, and I wanted to talk to you a little bit about that. I also wanted to really thank Marla Perez Davis, Dr. Perez Davis, for her great partnership with us as we're going and developing technology. So what I thought I'd do is go over some of those, and if you'd go ahead and go to the next chart, please, even after this title chart. And I'll just talk about some of the programs that we have. what we have following me is in a number of these cases, there's a number of programs that are particularly good for and opportunities for the participants here in Ohio and Toledo area to join what we're doing. We want to go over some of those. Those that we have a panelist coming on, I'll kind of identify as we go on here, but then you'll get more detail as the day goes on. But one thing I'll talk about in our portfolio is one of the strengths we have is we deal with all the way from very low tier what we call technology readiness level, things that are just kind of in the concept stage or in the laboratory, to a mid technology readiness level where we're demonstrating them, on a ground facility, that sort of stuff, and then a very high technology readiness where we're actually flying things. So the strength of our organization, I like to say, is our breadth. And as we go along, really, our need for drive for exploration helps drive the technologies that we need, but then our technologies help drive that exploration. So it's really exciting for us. What we have here is I've listed as 5 major categories. I'll just talk about each one of those briefly. In the early stage innovation category, we have NASA Innovative Advanced Concepts. This is a program that's a solicitation every year. What we do is give out a solicitation, and really the only thing you need to have is a revolutionary idea that doesn't violate the laws of physics. And from there, we allow it to develop. And even in this case, we have one that's already developed up to the point where we're planning on flying it on the moon. That typically gets about 1/3 of the proposals from government, 1/3 of them selected are from industry, and 1/3 are from academia. And we don't try to do that; it just works out. Good ideas can come from anywhere. We have Space Tech Research Grants, which is, I'll have one chart on it, and then Dr. Harry Partridge from Ames will give you more information on that particular program, and that's focused on university grants. We have a internal funding for Center Innovation Fund and Early Career Initiative. The Early Career Initiative is one of my favorite programs that we have because it allows our young folks and early career folks to be in the lead and innovative. Under the next category of partnerships and tech transfer, we run the technology transfer office for the agency, and Harvey Chavez, who runs the Glenn Tech Transfer Office, will give a little more talk on that. Prize and challenges is another great area that we have a lot of participation in and a lot of great ideas, and Dr. Amy Kaminsky will be talking about that. And then the third one on that list, iTech, is actually one we don't have further discussion at the panelist level on. But what iTech does is looks for reaching those companies that haven't really dealt with NASA before. And what we do is try to understand their technologies, evaluate them, see if there's something that's interesting to us, but also with entrepreneurs are involved, and they look at investing in. And in fact, this afternoon, we've got 10 Ohio tech startups participating in what we call an Ignite the Night event. And so we're looking forward to that. That'll be an exciting thing that's going on. We run I was thrilled to see the Congresswoman Capter talk extensively about the SBIR program that we run, Small Business Innovative Research and Small Business Technology Transfer. And we'll talk about a little bit more about that, but Janelle Steele will be talking further on. And then when we get to the tech maturation level, we have what we call our game-changing development. It's the idea is take things from early in the laboratory, demonstrate them on the ground, and get them ready for flight. With that, we have established a Lunar Surface Innovation Initiative, and I'm going to talk more about that because it's an exciting initiative that we have that I think is ripe for opportunities. And then finally, technology demonstration missions, small spacecraft flight opportunities. We work strongly with the communities and on flying things there. As an example, in our flight opportunities, we fly a number and work with. It's one of these also. It's a commercial venture. What we do is pair up and develop payloads that are technology payloads from industry and universities and government, and then help get those integrated into a number of different suborbital flight opportunities, whether it's high altitude balloons, multiple propulsion activities, and so on. Blue Origin, Virgin Galactic, and so on. And so we've actually flown nearly 700 payloads over the last several years there. If you'd go to the next chart, please. Jim talked quite a bit about our Artemis program and how the moon is a great proving ground for Mars, with Mars being one of our ultimate demonstrations. And what this chart just tries to depict is how we invest our money and how we can utilize the moon as a proving ground to go on to Mars. Not all the technologies that we have actually utilize and require the moon to go to Mars. Things like landing very heavy payloads. The entry, descent, and landing system for Mars is very unique because of its atmosphere. Jim talked about that. That's one that precision landing part of that we can demonstrate on the moon, but the entry through the atmosphere is something that's unique for Mars. Advanced propulsion. We'll talk more about some of these as we go on. And then a number of the demonstrations there that are listed on the moon, we utilize the commercial lunar payload services that Jim talked about as a way of early demonstrations of our technologies and leading on to a number of activities that are listed there. So if you go to the next chart, what I'd say is we have 4 technology thrust areas, and each of those are designated with a one-word title. In this case, it's rapid, safe, and efficient space transportation, which we like to call GO. And I'll introduce each of these thrusts in the next few charts. But for the GO, what we have is mission objectives that we're listing there. I won't list all those other than the first one is enabling human Earth to Mars round trip mission durations less than 750 days. What we really want to do is find a way to get to Mars and back. The extra complexity of a human mission is the round trip nature of it, and in order to do so at much lower time intervals, cutting it in half roughly, is to use nuclear propulsion technologies. So we have a number of investments in that for nuclear thermal and nuclear electric propulsion. And the electric propulsion, our center that we go to is Glenn Research Center. They're the experts there, and we're built to that mission with that potential technology. We are building now the solar electric propulsion system that's been mentioned a couple times already. It's the Hall thrusters that will be the foundational power system for the Gateway. That also is led by Glenn. And then another activity that I'll highlight on this page is the cryogenic fluid management. Glenn is one of our lead research centers for cryogenic fluid management. And if there's this is one of the most critical technologies we have that's enabling for us to have extended duration missions on the moon, as well as the transportation system to Mars and other activities. So it's critical for us to get long-term storage with no what we call boil off or loss of fluid as we go with a number of challenging fluids, including methane, oxygen, and hydrogen. We rely very heavily on Glenn for that. So if you go to the next chart, the next category of our thrust is what we call land, or expanded access to diverse surface destinations. There's a number of technologies we're investing in this area as they're listed here. A couple of them are, in fact, 2 of them are flying to on the way to Mars right now, and I'll talk about those a little bit later because we have one chart on some of the technologies we have on the Perseverance vehicle, Mars Perseverance 2020. There's a number of technologies that we're also developing that are useful for both moon to demonstrate global access and very precise 50 meters accuracy. In fact, the next Mars mission, the Mars sample return, really was going to need we've given it capability through terrain relative navigation to get to much more complex sites and more hazardous sites that we can avoid the hazards we're going down. But with that, then we need to return with another vehicle that gets very, very close to that. And so that will be another critical demonstration of that technology that will feed onto human missions. Next chart, please. The third category of our strategic thrust is live, or sustainable living and working farther from Earth. You can see a number of activities there listed. Regenerative fuel cells is a critical area that the expertise at Glenn is our lead for that, as well as the surface power. And with that, Jim mentioned it earlier when he talked about the Kilopower project. Kilopower was a Glenn-led activity. They worked closely with the Department of Energy and demonstrated a 1 kilowatt system at the Nevada National Security Test Site and did a phenomenal job in a very low-cost system to demonstrate a failure-tolerant system that could operate on the moon. What we intend to do is kind of enlarge that system to around 10 kilowatts or maybe a little more to power the moon, which will also feed forward directly to Mars, all led by Glenn. In situ research utilization has been mentioned a couple times, and what I'll do is, and as well as in-space manufacturing, these are very critical technologies for this. But what I'll do is skip forward. If you go to the next chart, please. So what we have established, as I mentioned, is a Lunar Service Innovation Initiative. And the idea behind this is let's get the broad community of our industry, our academia and government through both in-house efforts and public-private partnerships to develop transformative capabilities for lunar surface exploration. It is a place for us to gather and collect and come up with strategic plans that not just for NASA's interests, but those of academia and industry, and those that might want to commercialize and develop commercial capabilities for the moon. What we have done as part of that is established what we call a Lunar Service Innovation Consortium. It's comprised of academia, industry, nonprofits, other government agencies. We have Johns Hopkins Applied Physics Lab is administering this program for us. What we did is we started the consortium in February 28th was a kickoff. Our intent is to have the consortium meet as a whole about twice a year. In October of this year, it'll be a virtual event, but it'll be hosted by University of Arizona State. And then every 6 months or so, we'll have a get together. And what Johns Hopkins has led is forming six focus areas, 6 focus teams. Those are listed there. Mitigating the dust. The dust is very hazardous on the moon. It's also actually hazardous on Mars for different reasons, a little bit different activities, but it's a critical for us in order to get to a 2024 landing and then a sustainable presence to develop mitigation techniques for that. Sustainable power is another area. We've talked about that, not just with the nuclear fission system, but with solar arrays and regenerative fuel cells, and we'll talk a little bit more about activities that we have on a prize challenge in this area as well. But Glenn is our lead for that. Surface excavation, living off the land, and construction of facilities like landing pads or other things. Managing, accessing extreme areas of the moon, and so we will have rovers that'll go around, but also we have planned little mini scouts, if you will, scout rovers to get to really difficult areas and extreme environments. Then the equipment that we have has to operate in some of the coldest places on Earth when we're in the lunar night. And so what we've done, and if you could go ahead and go to the next chart, please. But there's over 6, and what we've done is each of those 6 focus areas that I mentioned, we have focus groups that meet on a monthly basis. And there's over 160 organizations that are meeting really monthly with us across all these things. And really, it's been a really exciting time. We have a newsletter now that's coming out on a monthly basis by Johns Hopkins, APL. And if you'd like to participate in this event, you can find it pretty easily. Google it, but lsic.jhuapl.edu will get you there. I'd really encourage people to check it out and see where we are. So far, when you include the broader LSII and the participation that we have there, along with the consortium, we have engaged 232 organizations across the U.S. and we started LSI, the consortium, in February. LSI is a little bit longer, and you can see the distribution around the ages around the U.S., including the Ohio and Michigan area there. And you can also see our representation is we think a very healthy mix of industry, academia, government, and nonprofit. So it's an exciting event that I'd encourage you to check out. Next chart, please. The final of our 4 thrust areas is explore. And the idea behind this is to enable transformative missions and discoveries. We have a number of activities that are depicted there. On-orbit servicing, assembly, and manufacturing is a critical area as we're going forward. The surface robotic scouts that I've referred to before, things like bulk metallic glass gears, and actually tires. Tires are something that there's expertise at Glenn that's helping us. Capstone is a fun mission. It's going to be a CubeSat, about what they call a 12U satellite that will actually be the first flight. We plan to fly it next year to the Mars and cislunar environment, to the Moon lunar cislunar environment, and it's called a Capstone. And the great thing about the Gateway is it will be in a pretty stable orbit, but it's not completely stable, and we've never actually operated in the rectilinear halo orbit before, near rectilinear halo orbit. And so this will be a demonstration before we actually go there with spacecraft as we go forward. So next chart, please. So right now on the Mars 2020 mission, we have 4 instruments from Space Technology that we contributed to this. And I'll just go over those fairly briefly. There's 2 of them, 2 of which are operating during the entry, descent, and landing phase, and then 2 of which are actually on the rover, Perseverance rover, they'll be contributing. We've mentioned most of them before. Medley is basically a next generation sensor suite that will help inform us of the temperatures and pressures and the profiles that come in, and then help us improve our models and then forward to larger vehicles as we go. Terrain relative navigation we've talked through a couple of times through the briefings, but it's a real-time hazard avoidance using using images that are taken every 10th of a second on the way down and comparing it to a database and using that to decide where to land and where to avoid hazards. Then on the Perseverance vehicle itself, one of them is MEDA, Mars Environmental Dynamics Analyzer. It's a weather machine. So to provide measurements of temperature, wind speed, and direction, pressure, relative humidity, and probably most importantly, as I talked about on the concern on the moon, is the dust size and shape and how that affects. Because you can kind of think of dust is about you don't understand weather on the Earth unless you understand the humidity and the moisture in the air. Similarly, on Mars, you don't really understand the Mars weather unless you understand dust. And so that we're looking forward to. And then MOXIE is the, Jim talked about this, and it will demonstrate a way to produce oxygen from the Martian atmosphere of carbon dioxide for propellant and breathing. It'll be the first time of living off the land, if you will, of a demonstration that we'll have. Next chart, please. Then I'll just very briefly talk through a few of the programs that are coming up that you'll be getting more information as we go today. Janelle Steele will be talking to you about the SBIR STTR program. And I'm thrilled. I won't go over the numbers again because Congresswoman Kaptur talked a lot about the reach of our program. And so you can see them there, and I won't repeat them since she talked about them. But this is I think one of our flagship programs in tech transfer. It is a critical program for us and the best program that we have for reaching small businesses, and also through the STTR, through university cooperation with those businesses. And so what we're trying to do, as you'll hear as we go on, is a number of innovative ways to really broaden and expand what we do with the SBIR program, including what we have authority for a pilot program is to award multi-dollar sequential phase 2 contracts, which we plan to do this year. And so instead of being limited to the $750,000 or so or $1 million-ish level, we can, in one award, get up to $5 million. So we're excited about that opportunity and a number of other ways that we're trying to utilize our SBIR program to reach out to even further to entrepreneurs and help them. And by doing that, we're helping ourselves. Next chart. Amy Kaminsky, Dr. Kaminsky will be talking a lot about our prizes and challenges, and I will talk about one of them in particular in another chart coming up. But we have a number of projects or programs in our portfolio, including a Centennial Challenge, which are millions of dollars type prize challenges, our NASA Tournament Lab, which are kind of a little bit faster moving, hundreds of $1,000s that we have, Space Apps Challenge, as well as student challenges as we go on. So we have a lot of opportunities. It's a really great area. I'll come back to I'll touch back in a chart a little bit later on how this fits into an overall concept for the lunar surface. And then Amy will talk to you about this program as well. As you'll see, some of our key challenges, one of our key upcoming challenges is going to be led right here out of the Ohio region and Glen. Next chart. Our Space Tech Research Grant opportunities is Dr. Harry Partridge will be talking about these as we go on. But we have a Space Tech Research graduate research opportunity, which we think we have the best program in the government. Because what we focus on is not just the student, but we give the students a lot of opportunities. Well, when it'll be virtual, it's virtual now, but as we grow, a lot of opportunities to work with centers, and we also focus on their advisors and make sure they're part of this as we're going forward. We always pair subject matter experts with the students to really help and it's research for us. It's not just a fellowship. Early career faculty is focused on outstanding early career faculty members. Early stage innovations is kind of those more advanced faculty members, and the idea is that's more likely to be teamed with other universities, industry, and nonprofits. And then the last two, we just introduced a lunar surface technology research opportunity, or what we call LUSTER, as part of our Lunar Surface Innovation Initiative. This is an open opportunity right now in the proposal development phase. The idea behind this is it's most of what we do is really early stage and early concepts, but in lunar surface technology research, we kind of go a little bit closer to something implementable. And the university-led efforts will address high-priority lunar surface challenges. And they're short duration, 2 years, high-value grants, about $2 million each, with an emphasis on technology development. And also, we're looking for potential infusion of this as follow-ons for this. And so it's paid teaming with the universities, industry, and nonprofits are very strongly encouraged. And then finally, we've had a program that's been going on for about 3 or 4 years now. It's called Space Tech Research Institutes. We have a call out right now for 2 different topics, but the university-led, multidiscipline, integrated. It's got to be at least three major universities, and more encouraged, but at least 3 that are primary universities that are involved with this. We pick the topic, and then but beyond that, it's wide open for the proposal. And they're 5 years long, $3 million a year. So the first, we've had 4 of them ongoing right now. They're doing fantastic, and we've got a call out for 2 more. Next chart, please. Our tech transfer program, we're also trying to do it. We run what we think is the best tech transfer program in the agency. We might be a little biased on that, but you hear more about that as we talk a little bit. And I'll just highlight a couple things that are going on because we also are looking for ways to really reach. We think we reach out very strongly with our technology transfer, our software licensing, licensing programs and stuff like that. And through its things like the Startup NASA program, the University T2 Tech Transfer University, which Cleveland State University is part of. In that, we try to bring NASA technology to the classroom. We also have what we have ongoing now, and I'm sure you'll hear more about it in a little bit, is the NASA Startup Studio Ohio. NASA Startup Studio Ohio. It's underway, and it's wrapping up around September 2nd. But it's been an 8-week program where about over 24 entrepreneurs have formed teams. And they learned we've got technologies that are in NASA technologies that are potential for them. They learn in this how to build a product line and business around the commercial potential of NASA technologies. And I believe there's like 9 technologies that we've picked in this, 6 of which were developed by Glen Research Center. Next chart. And then, like I said in the beginning, the strength of our office, I think, is our breadth. And what we're really striving to do with our programs is to look at how we can utilize them in an integrated manner to help solve our problems and reach a broader part of the community to help us. And so we've just listed here, these are all collaborations that are active, ongoing, that's helping us on a Lunar Surface Innovation Initiative. The next step, broad agency announcement is the first one there. We've had this for over a year now, a year and a half, for in situ research utilization development activities, and you can see the companies involved. SBIR and STTR we've talked about, and what we do is we focus a lot of our subtopics on areas that are directly relevant to our Artemis or Artemis program, like surface power, dust mitigation, extreme access, ISRU. You might recognize those terms. The Centennial challenges that I talked about earlier, we're in final formulation for releasing a Watts on the Moon challenge for solar, for helping us on solar power or power, sustainable power, I should say, and an excavation and manufacturing and construction coming up after that. We have a number of activities in what we call our COSI, or Center of Excellence for Collaborative Innovation, including we just recently did a Honey, I Shrunk the Payload challenge. We talked about those Scout rovers. So this was let's get from the community through a crowdsourcing effort of what kinds of things could we do on a very small platform that might not be much bigger than a cell phone in terms of its base. And we've done what's known as we've employed the company Yet2 for technology searches. We don't know all the activities that are there. We don't always need to own them. And that's been extremely fruitful for us. And you can see there's 4 searches that we've done just recently. The NIAC program, as I mentioned, we had one phase 3 from Carnegie Mellon that is now actually targeting exploration of lunar pits, which is something that we're hoping to develop and fly. Our early career initiative is one that we utilize our internal workforce in the early careers, as I mentioned. We selected last year 7 of these. We've got somewhere around 12 or so active, and we're just about to select several more. Early career faculty, we have a topic on dust behavior modeling, and then we have a couple of several opportunities there. And I have a chart coming up on that's a little bit that shows all our opportunities. So next chart. Here it is. And so here's one thing it's really hard. I know it's very hard to get your arms around, especially when you're new to NASA or new to space tech, because we have so many solicitations that are basically going on all year long. And this is in one chart attempts to show kind of in a typical year. These are the it's kind of typical year, but it is our past year where things were. Those that are in blue are things that are solicitations that have been open. Now that the proposal period is closed for this year, but they'll come back next year. The green ones are where the proposal periods are still open. And I'll mention a few of them. Tipping Point, we expect multiple awards really in the next couple months. Within the next couple months, we expect to make a number of awards. And we're focused on a lot of flight demonstrations in cryo fluid management, in entry, descent, and landing, and well as lunar surface technologies. So that's primarily focused around industry, with partnerships from universities and so on. We mentioned the SBIR programs, including the sequentials. We have an announcement of collaborative opportunity where we just offer up NASA in a non-reimbursable arrangement. We offer up NASA technical expertise as facilities that can help a company to develop their commercial product. Flight opportunities, I mentioned, we've flown over 700 or almost 700 payloads over the last several years. And that solicitation is closed, but it comes again early next calendar year, and so on. Let's see, I'll just not go through all of these, but I think I'll go with that. You can go to the next chart, but see, because all those I think I mentioned. And then just to my final chart, then open up for a few questions if we have time, is just kind of by the numbers. This is a very typical year for us. We're just about ready to close out FY 2020. So here's data from the FY 2019, fiscal year 2019. We, on a typical year, will evaluate over 3,500 proposals. We'll select over 700 of them. We have active right now over 350 university partnerships with over 100 universities. We have well over 50 projects leading to flight demonstrations. We have over 1,000 active technology projects. In our tech transfer over 2019, we had over 2,300 software releases. We have over 400 industry collaborators and over 9. And if you measure a transition as being somebody else picks up the funding after we've done, and this number is almost certainly very low, we've had over 900 of those in the last 10 years or 9 years. And with that, I think that's my last chart. So I'll open up for questions.
Thank you, Jem. Yeah, we're getting lots of feedback here. Everybody loved the presentation, and I'm getting lots of questions that was a lot of information. So just as a reminder, the University of Toledo's College of Engineering will be making a recording available of this entire event. It'll be on their college website. So it's utoledo.edu/engineering. So you can be checking back next week if you want to go back through any of those specific slides that Jim covered. Jim, let's start with this question. What near-term space technology or challenge can people tuning in today help NASA overcome, or what can they do to help with what's needed?
Yeah, it's a great question. We have something always on the horizon. We'll be opening up the small business ones. The next round of those of SBIRs, I think we're going to try to move it up a little bit from, it was January of last year, but I think it's going to be around November. Let's see, we have research grant opportunities coming on almost all the time. Those solicitations will come out early next calendar year, most likely, for most of those as we go forward. We have a big idea challenge that's open for students right now. And you'll hear a lot more about the prizes and challenges activities as Amy talks this afternoon. We give out a solicitation for basically we have solicitations throughout the year, and you can refer to that chart that we have, what we call our money chart with the bars and stuff and the open challenges. That gives you a really good idea throughout the year of when our challenges open up. But definitely small business, definitely our research grant opportunities for universities. And then also, as I mentioned, I think a really good place to get engaged, even though it's not a place that we're necessarily going to announce specific, make specific announcements for funding activities, but the Lunar Surface Innovation Consortium, I really highly encourage you to check it out and see if you want to participate, because the whole idea behind that is we're trying to get that to be a forum where everyone that's interested in a certain area, and we have those 6 focus areas, have an opportunity to discuss and interact, provide their recommendations for priorities. And also we're encouraging and getting great response from our larger industry partners to have them help be mentors as things develop. So hopefully you can look at that chart and that gives you a really good 1 year glance at when our solicitations go out.
Great, thank you so much, Jim. You actually answered the next question on the list about how small businesses and universities can get involved. So let me ask you one final question before we wrap up here. What advice do you have for the folks who are tuning in about how best to seek out these collaborative opportunities? We've talked about so many. What's the one piece of advice you want to leave folks with?
Well, yeah, that's a great question, and I'm not sure I can keep it to one. But the first thing, there's 2 things I would say right off the bat. First, think about where your passion is. Following your passion will almost always be a successful route for you. And then the other part is take advice from our Mars 2020 rover, and perseverance is just never give up. Yeah, and just look for different opportunities. And those opportunities come not just from us. You see our list, but there's a wide range of opportunities across NASA with our STEM engagement. We work very closely with those and the UREP and other solicitations that they have. And so what I would say is just follow passion and persevere.
Very wise words to leave us with, Jim. Thank you very much. And thank you all for tuning in. We are going to take a short break here. We will start at 12 noon on the dot. So this gives you a short break to take care of some things you might need to, and we will see you back here in 17 minutes. Thank you very much, guys. Welcome back. We're going to get started here in just a few minutes. In the meantime, while we're waiting for everybody to reconvene, I thought it might be fun for all of us to get to know a little more about the collaboration that exists between NASA's Glenn Research Center and the University of Toledo, specifically our College of Engineering. The U-Toledo College of Engineering began partnering with NASA Lewis, which is now NASA Glenn, to provide graduate courses on site in the 1960s. Over the years, some 300 NASA employees were able to obtain graduate degrees through the University of Toledo. And thanks to all of these rocket alumni, U-Toledo continues to have a strong relationship with NASA. And with the help of Dr. Theo Keith, a distinguished university professor emeritus, and countless others, our College of Engineering has maintained a group of contracted U-Toledo employees who work on site at NASA and who have been continuously funded for the last 44 years. And as Congresswoman Capter mentioned earlier, the University of Toledo has received more than $25 million in research funding from NASA, including just over $14 million for collaborative projects with the NASA Glenn Research Center. We're coming right up on noon, so as soon as I see all of our panelists log in, we will get started. All right, it looks like we are ready to go, so let's meet our next panel, who will be discussing prize competitions and internships. Dr. Harry Partridge serves as the Ames Center Chief Technologist. He is responsible for identifying, defining, developing, and integrating new and emerging technologies for application to agency and national goals through the NASA Space Technology Mission Directorate. Dr. Amy Kaminsky serves as Program Executive for Prizes and Challenges at NASA headquarters in Washington, D.C., where she develops strategies to expand the space agency's use of open innovation methods in pursuit of its mission. Ms. Vanessa Webbs is currently managing the NASA Internships Program at the Glenn Research Center. She is responsible for the recruitment of students and mentors, as well as the design, development, and management of the project that serves over 300 students annually. Dr. Lindsay McMillian Brown is a researcher at NASA Glenn Research Center. She interned with NASA in 2009 and 2010 and became a NASA Pathways intern, which is a co-op program, in 2011. That converted to a full-time position for her in 2019. Dr. Partridge, I'll hand it over to you. Dr. Partridge, we're having trouble hearing you. I see that you are not on mute, but maybe we should start with Dr. Kaminsky while we see if we can figure out the technical challenges here that we're having with Dr. Partridge's technology. So, Dr. Kaminsky?
I'm here.
We can, thank you. We'll get started with you.
Okay. Slide.
Yes, if you just let them know which slide you want to be on, we will get started.
Sure. We'll just go to the title slide. Thank you so much. Well, it's a pleasure to be here with everybody today. And I'm really excited for the opportunity to share with you a bit about NASA's challenge. Hopefully, this presentation will give you a nice understanding of the sorts of things, the sorts of offerings we have, and ways that you can participate with us in these activities. So we'll go ahead to the next slide. So in order to talk about prizes and challenges, I often like to start here with what traditional innovation looks like at NASA, because prize competitions are definitely not what we think of typically at NASA as our sort of long-standing ways of doing things. They are a new way of pulling innovation into the agency. By way of comparing and contrasting, at NASA, NASA's been around now for 60 years. We have an incredible workforce of scientists, engineers, and so many others who are responsible for managing programs and seeing the implementation of them, doing research in labs, and so forth. In addition, we partner traditionally also with aerospace companies, with academic experts in science and engineering, as well as other government space agencies around the world. And in those collaborations, we tend to use mechanisms like contracts and peer-reviewed grants and cooperative agreements with our intentions like memoranda of understanding and agreement. And these have served the agency really well for quite some time. So we'll go to the next slide. So prizes and challenges are an additional tool that is relatively new to the tools, the innovation tool suite at NASA that complements these other approaches and brings with it one of which is the fact that with prizes and challenges, we widely communicate opportunities to really, well, widely into the world. Typically with grants and with contracts, it tends to be a small subset of communities, of individuals and communities around the world that pay attention to those sorts of opportunities, right? They are read by a narrower group of experts who are interested in those particular opportunities and can count on them coming up from NASA from year to year. With prizes and challenges, what we're seeking is to go out beyond the usual suspects, if you will, although we certainly do get participation and we welcome participation from folks in the aerospace industry and who are part of aerospace departments at universities and so forth. But we're also trying to bring in anybody and everybody who might have an interest or a way of solving a particular problem. And so by doing that, by offering prize competitions and saying, hey, here's the problem we're after. We are seeking this sort of technology and we're challenging you to come in and develop it. We're diversifying and we're increasing the base of our community of solvers. And what NASA is getting out of it is solutions. So with grants and with contracts, of course, proposed, and then reviewers evaluate those and say, I think this one has the best shot at delivering on what they say. It's all well and good. Prizes and challenges turn that model around a bit, and they invite the participants to actually develop the solution, and then they receive an award after based on the solution that's delivered. So it's a turning of that model. The prizes and challenges we've found can also attract an investment greater than the award amount. So we have multiple teams going after a particular competition, and we find that this really stimulates innovation and creates new markets for the nation. And in addition, by participating in prizes competitions, we have found that teams really get a spotlight on them. There tends to be a lot of media attention around many of our competitions, and so this is real visibility for them. Next slide, please. So at NASA, we've run more than 350 challenges over time, over about the last 15 or 16 years. And they tend to fall into 4 different categories of initiatives. One is our Centennial Challenges program, which focuses ultimately on developing hardware prototypes, demonstrating the ability to solve some really hard technological problems by way of ultimately having it could be a head-to-head competition where you bring your, or we have judges go to evaluate it at the location of the competitor. We have the NASA Tournament Lab, which runs a number of challenges that tend to focus on particular individuals or projects' interests in solving problems specific to that problem for NASA. This could be an improvement to software. It could be the development of an algorithm to speed up processes. It could be the development of any kind of application, videos, animations, that sort of thing. We have the Space Apps, International Space Apps Challenge, which has been around for 8 or 9 years. It's a 48-hour hackathon, data hackathon that goes on every year and invites folks around the world to come together to solve problems of how to create more use from, more value from NASA and other space agencies' data. And then we have student-focused challenges, which are exactly that. They are challenges that are focused on attracting students, K-12, as well as undergraduate and graduate students to help NASA solve some tough problems. Opportunities can be found on our NASA Solve website. You can see the address down at the bottom of the screen. Next slide, please. So how do you fit in? Well, there are 3 different ways in which we interact with folks outside of the competitions. Of course, the first is that we need competitors or we don't have a competition. So we encourage consideration for being a competitor. Another is as a competition judge. We definitely need the expertise of individuals outside of NASA to evaluate competition entries, and then as supporting partners, because we have found that there is real power in collaborating and mingling ideas, mingling resources to make a competition just absolutely stellar. So I'll just delve into these a bit more. If we go to the next slide, please. So participating as competitors. So our competitions tend to attract both teams of individuals as well as individuals themselves as a single team. They come from universities, they come from small businesses, they can be entrepreneurs, they could be individuals who just enjoy tinkering in their garage. We've seen that, and computer coders and on and on. They come from the United States, they come from around the world. And we found that competitors tend to be attracted to our competitions for 4 main reasons, which we call the 4 Gs: gold, the award associated with it, gold, good, doing it for the benefit of society or the ability to make a difference in the world, guts, just for the sheer, the sheer challenge of it, and glory, so the visibility. Our awards do vary. Sometimes we have cash awards for our competitions, but others, like with the International Space Apps Challenge, we offer bragging rights and visibility. They don't have dollar amounts associated with them. Some of our cash awards are open only to U.S. citizens because of the legal authorities under which some of our competitions are run, but others, particularly the ones that are run under our NASA Tournament Lab, are open to all entities around the world to win those, to vie for those prizes. We have seen teams go on to do really incredible things because of the visibility that they've gotten from the competitions. We have that many will go on to pursue other NASA research and development funding opportunities in STMD and around the agency. Others have gone on to create companies or to build companies, grow companies based on their participation. And some of those companies have even come back to become NASA contractors. So we've seen the full circle. And again, you can find all of those opportunities on NASA Solve. Next slide, please. So competition as judges, again, we're looking for that expertise to come in and to be there to evaluate entries. The time commitment around this could really can vary based on whether it's an on-site competition where folks come together for a couple days for the competition, or sometimes we even have competitions, many times we have competitions that are purely, you're looking at virtual submissions. So they're software and things like that, where those things can, can be evaluated from your own location. And then participation as partners. So private sector entities can co-sponsor prize competitions with NASA. We have the legal authority to make those connections and accept award funding, prize funding. We can accept funding from outside sources for the administrative costs associated with the competitions, as well as in-kind support. Small businesses can also, and others in the academic community and so forth, can support challenges as mentors. They can also be incubators or accelerators of technologies. We see this, for example, with our Space Apps Challenge, where around the world we have different communities that host space apps, and they will bring in, part of the incentive to the participants, because there are no cash awards, is the fact that they'll bring in individuals who can help them further their projects beyond the time of space apps. And then lastly, we do welcome investors and venture capitalists to our competitions to come in and to see the competitors in action. And if they see, promising companies, they too can help to make them grow. Slide, please. So I did want to mention one really exciting competition that is coming up imminently. We plan to, toward the end of next month, launch our newest Centennial Challenge called the NASA What's on the Moon Challenge. This challenge is focused on developing power systems for the distribution, the management, and the storage, I should say, of power to support upcoming lunar missions. We are working on this competition in close partnership with Glenn Research Center. And we are just so pleased in the collaboration that has gone on to develop this competition. It is going to open the first phase of the competition as a $500,000 competition. It will be, we're starting with a design competition, so this will be on paper or on screen, if you will, for starters. And that will carry on for about 6 months, and then we will be evaluating and making awards for the first phase. And so long as there are promising, it looks like a promising field, we will open up phase 2. And we're looking at a total of up to a $5 million competition for this as we go into the next phase. So if you are interested in competing, please watch NASA Solve. If you are interested in being a judge, please let us know. If you have other ideas for how your organization might tie in as a partner to this competition, we are really eager to hear that as well. And then lastly, I'll leave you with my contact information on the final slide. And thank you so much. And I will hand it, am I handing it over to Harry, or am I answering questions?
We're going to do questions at the end. I see that Harry is in. Harry, I think you're trying to call in. Is that correct?
I should be on. Can you hear me?
Yeah, we can hear you. All right. Well, it wouldn't be a webinar if we didn't have at least one small technical glitch. So while we arrange your PowerPoint slides, Harry, we'll let you go ahead and get started. And when you're done, we'll hand it off to Vanessa Webbs to talk about internship opportunities.
Okay, it's a pleasure to be here today, and I'd like to thank everyone for inviting me to speak. I'm really pleased to be able to represent the Space Technology Research Grant Program. Claudia Meyer is the program exec for this program. The level 2 office, or the program execution, is managed out of Glenn Research Center. And I am the chief technologist at NASA Ames. I've Had the pleasure to be involved in the early stage programs for space technology for over 10 years since we've founded the program. And I've been involved in the Space Technology Research Grants Program since then. And so it's a pleasure to be able to tell you a little bit about this program. Can I have the next slide? So you've seen this slide that was in Jim's presentation. The purpose of this is to engage the academic community at all levels, everywhere from graduate students through postdocs, through professors, in solving exciting problems in space technology. It leverages what the universities bring to the research community. It covers a wide range of space technologies. I also say that everything that's done in this program is competitively selected. They're all done with research with peer-reviewed panels, which cover a diverse community of both government employees, NASA employees, academics, industry, and as a general rule, at least 50% of the reviewers are from academic institutions. So we really value that peer review process, and they select it. These are 5 solicitations right now that are under this program, and they cover a wide range of things. And you heard briefly about them, and I'll give you a little more details about those and as we go forward. Can I have the next slide? So this just shows the breadth of the program. It made a number of awards over the years. It's covered now most of the states, and we always pay attention when we get awards for competitive proposals from places we haven't funded. It covered a lot of universities, and interestingly, it covers a broad range of the space technologies. These are the 2015 roadmaps. Eventually, we will switch to the new taxonomy. But these work right now for us. We say that we cover the entire range of the space technology portfolio. And it shows you the number of awards in each of those areas. Can I get the next slide, please? So the space technology graduate research opportunities is a really exciting program that looks for graduate student researchers interested in space technology and innovative technologies and so forth. The previous version of this was called the Space Technology Research Fellowship Program. The name was changed to emphasize the focus that it's on graduate student research. It's a competitive program with other similar programs. We fund somewhere on the order of 60, sometimes a little more, awards per year. It is competitive both financially, and it has some really interesting aspects to this. It covers the entire portfolio of space technology. It doesn't have to be a project that is currently being funded by NASA. It's anything that's in the roadmaps or is open to getting an award. That gets a NASA collaborator, which helps introduce the candidates to a broader community so that it furthers their career as they go along. There's a visiting technologist experience where they get to spend time at a NASA center or nonprofits or other government labs to expand their range of experiences. What we look for is people who are innovative, creative, and have a real interest in space technology. So space technology is broad; it covers a lot of things. But we're interested in funding people who have an interest in space technology, no matter whether or not they work for NASA, industry, or they're going into academia. All of those are fine. It funds U.S. citizens and permanent residents. Again, it is competitive. The application is not onerous. It's pretty much similar to what somebody would use to go to to apply to a graduate school program. It covers both master's and PhD students. And again, we fund about 60 or so of these a year. It's been exciting to see this program grow. We've now had, not only are we have civil servants who were former recipients of these awards, we've had professors who now had graduate students apply for subsequent awards. We've had faculty members who have then applied for early career faculty. I mean, just all over, I mean, just a huge impact. And some of the impact is technical, but some of it is cultural. It really increases the collaboration between the NASA research community and academia, particularly the advisor and that group's other students that work with that advisor. And it also has infused new ideas into NASA. So I think it's been a tremendously successful program. The next slide. So these are early career faculty and early stage innovation. These are low TRL. We're looking for transformational space technologies. They are focused solicitations. There's one per year. Early career faculty, we award somewhere on the order of 8 to 10 per year. Early stage innovations is on the order of 12 or 13 per year. They are focused topics. The topic selection process is, we look at many things. One, it has to be an innovative technology. We look at what the potential for the infusion of that technology is into NASA programs or down the road or for further development. We look at what other agencies are doing. How does it differ from what other agencies are funding? So there's a lot to come up with the topics for this. And part of the reason for various focus topics is to make the selection percentage, to keep it very reasonable. We don't want so many proposals. One, it becomes very expensive to review them, and then it's a lot of work for very little return on investment. So we do focus them on topics. They can collaborate with nonprofits and business, but 70% of the funding must go to universities. There is the early career faculty for this year. Those announcements should be made soon. The early stage innovation for this year is just starting the review process. But again, the solicitations, they come out each year in the early part of the calendar year. The next slide. Lunar surface technology opportunities is new this year. It is a little bit higher TRL than the other programs, but it still leverages what the universities can do. It's part of the Lunar Surface Initiative program. This is the first year, and it had released six topics, and I'll show you those in just a minute. One of the things that's interesting about this is that infusion is particularly strong, and we're expecting for successful efforts that there will be opportunities for post-award to further develop it and possibly even transition this to lunar surface operations. The organization submitting must be an accredited university. The PI must be a professor at the university. It's open to a number of types of professors, but it must be a full-time professor at the university. Since infusion is so important, 40% of the funds can go outside of the university community, including nonprofits and industry. This solicitation is currently open. The NOIs were due yesterday, as a matter of fact, and it's getting quite a positive response. The next slide. This shows the topics that are open for this year. They are in 2 of the 6 focus areas of the LSII. Future years will have additional topics with additional focus areas. But these are the topics that were out this year. And again, the NOIs were due yesterday. They weren't required, so people can still submit proposals. Proposals are due early September with award sometime in May of next year. The next slide. Space Technology Research Institutes are multi-institute awards. And what we're looking for here is where ideas with a vision for how to take a technology forward and infuse it, but it needs to be more than just the sum of a bunch of individual grants. We're really looking to tie them together. And so 70% of the award must still go to universities. They're competitively selective. You have to have at least 3 universities involved, and 70% of the funding must go to universities. They encourage diverse participation. The awards are 5 years, so they're $15 million over 5 years. The institutes are expected and empowered to implement their own review process. So, I mean, when things are going to change over 5 years, particularly as they go, they're expected to have an external advisory board to advise them on where to go. And so it is a quite powerful way of leveraging the academic community. I see the next slide, please. So we have 4 current awards. The next 2, they actually closed last week. So we have the phase 1 proposals for the next round of the STI, and that call is out, so they haven't been selected yet. But the first 2, one was the US Comp, it's a carbon nanotube-based composite structural materials. This one was interesting, and it's a little bit higher TRL level. The goal is to obtain a TRL5 material, which meeting certain specific properties by the completion of the project. It also leveraged what's going on in the materials genome initiative, so the integration of computation, characterization, and synthesis to really accelerate the infusion of materials. What's interesting is while there have been other NGI-related institutes, what this one's doing is trying to push the technology, the TRL level, up so that the product is I mean, they had TRL5, so it's a little higher TRL level than what other agencies have been funding. The other one is cubes. This is a really exciting one where it's using a multi-organism biomanufacturing systems that have a number of applications, so everywhere from media to nutrients to plants. This is run out of Berkeley. It's a quite exciting institute. The next slide, we have 2 institutes. Whoops, we skipped a slide somewhere. The slide that's missing here is it shows the 2 on the smart habs. There are two institutes which looking at in a broad sense is looking at what cyber physical systems did for the Internet of Things. Well, how could you restructure a habitat? So it's the automation, the the human robotic interaction, the advanced manufacturing, the robotic repair, the autonomy to make a habitat work. And there are 2 funded, and I apologize, I'm not going to remember the names of them, but one's out of UC Davis and the other one's out of Purdue. And they're very strong. They've just finished their first year, and I think they're making very good progress. There are another call that is out, though again, those proposals were due last week. One is on entry systems, entry system modeling, how to improve our reduce the uncertainty and reduce the margins on TPS materials. And the other one is, well, how do you model larger electric propulsion systems in ground facilities? So two very exciting institutes, and I'll be very interested to see how those work out. The next slide. And this will be the last slide I'll show. I have other examples in there. This is just an example of some of the work that we have funded. This is one out of Case Western. It's using an ionic liquid membrane for CO2 capture. The initial results are extremely promising. The capture rate is very high. It exceeds what we can do with our typical zeolites by a significant fraction. And it'd be interesting to see how this technology gets developed and whether or not it can replace the carbon capture system that we use in space. And I'll stop there. It was a pleasure to talk to you. And the early stage program is really quite exciting. And thank you very much.
Fantastic. Thank you, Dr. Partridge. Next up, we're going to hear from Vanessa Webbs about internship opportunities. Vanessa? Vanessa, I need you to unmute so that we can hear you.
Okay, so you missed my fantastic opening. Let's try it again. Good afternoon. It's a pleasure to speak with all of you today about internships. I'll begin with an overview of Glenn programs and then move into the virtual internships. Next slide, please. At NASA Glenn, we have internship programs for high school students age 16 and older in their sophomore and junior years. Our college program is for undergraduate as well as graduate students. And we have a Pathways program, which is our co-op program, and that is an agency-wide program. In fact, that's a government-wide program. And we also have fellowships at various academic levels. Next slide, please. The application process begins at intern.nasa.gov for the majority of our programs. And this is where students can create a single application and apply to up to 15 opportunities across the agency. Next slide, please. All of our internships and fellowships focus on work that contributes to the NASA missions. Interns are members of NASA teams and are assigned to authentic projects, as you can see in these examples. We have a project currently offered in 3D printing, another one in cryogenic propellant modeling, and then we have one for STEM engagement, performance, and evaluation support. These are just 3 examples of the type of work that are available year-round for our students. Next slide, please. Okay, now I'd like to talk about our virtual internships. This summer has been NASA's first ever virtual, complete virtual program. During our spring session, however, we were required to shelter at home. And our interns across the agency had a choice of continuing their internship or to leave their internship. And so the majority, of course, decided to stay with us and work from home. And my team then spoke with each of our mentors, internship mentors, to make sure that they could reorganize the work so that, or reconfigure the work so that the students could continue virtually. Our IT partners had to provide a process to enable government computers to leave the premises and then to be safely returned, as well as provide ongoing support to each of the students while they were away from the center. We had to, in addition, consider issues of cybersecurity and counterintelligence. And there was just a lot to be explored that we would not have had to deal with were the students still on our campus. However, this was a precursor to our summer because at the same time, we were figuring out as an agency how to proceed, whether we would have virtual internships or no internships. And we developed a team that I was a member of, and we made recommendations to our senior leaders. And the decision, of course, was virtual internships. Next slide, please. Now, programmatically, of course, there were concerns about giving our interns what we promised, and that was the NASA experience. What would our interns need that was different working virtually than working on site? So we were concerned about our students feeling isolated or disconnected from their peers and mentors, working in different time zones and perhaps in environments that were not conducive to working all day. And so how would they be able to feel like they were actually part of the NASA family and as though they had a NASA experience without being able to step foot on any of our centers? So we came up with several ideas that would work well. The peer leadership program, as you see here, was the first thing that we instituted, and that involved the spring interns who had both experiences, on-site and the virtual, and they became, those who were returning for the summer became peer leaders. And they worked with our summer interns in terms of making sure that they had the guidance that they needed, the telework tools that they needed. They helped them with getting to know one another, even though they were not in the same room together, and gave them a feeling of being at Glenn and being able to tell them what that experience was like. We also came up with several other ideas. Next slide, please. And every internship session, we have a variety of events. And so that didn't change for the virtual. In fact, it increased for the virtual, again, giving the students the feeling of having a NASA experience. And so both the centers individually as well as the agency collectively created a plan to keep the students engaged and to provide them with as much on-site type experiences as we possibly could. So there were virtual facility tours, and there were opportunities to hear speakers from every center, all 10 of our NASA centers. And as you'll see on the right side of this slide, that the students were able to listen to and talk to afterwards people like John Mather, Nobel Prize winner, who discussed the James Webb Telescope, and also talked to Ann Bromer about the astronaut selection process. And as you can imagine, that was a big winner in terms of of a program for the students, very much interest in becoming astronauts, and at a place in their lives where they could actually think about that and not only dream about it, but begin to work towards that goal. And so we also wanted to make sure that our students got a chance to speak with people who had a variety of careers or different professions in STEM. And so there was an opportunity for mentors to provide some opportunities for them to speak to other people in their organizations. And so I think that when it comes to virtual internships, that's something that really works for us, and that we, of course, are going to continue that for the fall. And then spring, we'll see what's going on in the world and figure out if we can bring students back part-time or full-time to our actual centers. And that's it. Our next speaker is Lindsay McMillan Brown, and she will talk to you about her experience as a NASA intern. Thank you for your time.
Thank you, Vanessa. Again, hello, everyone. I'm Lindsay McMillan Brown, and it's my pleasure today to give you guys a viewpoint into the journey of a NASA intern, specifically my journey as a NASA intern. Next slide, please. So as a NASA intern, as Vanessa mentioned, you have the opportunity to conduct meaningful research. So here we have some photos of me as an intern with my mentor as we launched a high altitude weather balloon with solar cells attached to its payload. This is a method used to calibrate solar cells because we're able to get through a great deal of the atmosphere and we get a better understanding of how our solar cell will perform when it's in space. As an intern, you're always having fun. So on the back side of the payload, we had some extra room, and one of our colleagues had a space G.I. Joe, like astronaut, and we figured how cool would it be to send G.I. Joe to space. So we tagged him on the bottom, and at the bottom there, you can see an amazing picture photograph of G.I. Joe with the curvature of the Earth behind it. So that was just a fun thing, some play that you can do while you're working. Next slide, please. Also, there's a lot of work inside the lab, and in the lab, I conducted more meaningful and fun research. Here, I've collected some more images throughout my time. On the far left, you see I'm working on a sputter machine depositing thin films. This was with my mentor back in 2010. These thin films were for solar cells. In the middle, I have a few images of work that I did building a Mars Hopper in situ resource utilization experimental rig. And the purpose behind this experiment was to sequester carbon dioxide so that we could generate fuel for a potential return mission from Mars. And then on the far right are some recent pictures actually that I took of myself in the lab of 2018 when I was conducting degradation testing. So here what I'm doing is exposing solar cells to Martian dust simulant and then measuring them so that I can see if you were to undergo a really bad windstorm in Mars, how would our solar cells perform? Next slide. But also as an intern, there are lots of opportunities to see other labs and learn a great deal about the other research conducted at NASA. So here I have pictures of various robots and some tire research that I saw at the Slope Lab at Glenn Research Center. And also I was able to tour world-class facilities like our drop tower, which that tour is on the bottom right of this slide. And as we go to the next slide, you can also see the world's largest vacuum chamber, which is at Plumbrook Station, just outside of Sandusky. And that simulates the space environment. It is a miraculous piece of machinery or equipment and facility to get to see. So to stand in that and see how large it is was really an amazing experience. Next slide, please. So Also, as an intern, be it virtual or in person, there are so many opportunities for you to practice your science communication in all of its forms. You will make your posters, you'll give some oral talks, and there are many opportunities for written peer-reviewed publications to come out of your internship. I can say for myself that practice does make perfect. As you can see, my rookie year with a poster in 2010 on the top left, and then on the bottom right in 2019, I actually won Best Poster at the biggest conference for photovoltaics in my field. So I was very happy, and it was fun when I was putting this slideshow together to see kind of my scientific journey and how NASA has fostered so much growth over the years for me. Next slide. Also, one of the unexpected benefits for me personally, but a dramatic benefit of the NASA internship experience is you meet the most amazing people. I've collected here some photos of all the different people that I had the opportunity to meet. They range from my intern peers, so the cohorts that I was with, many of whom I'm still connected to now, and we, keep in touch periodically and see how we're all doing in our careers. I've also met astronauts and senators and center directors and authors and mentors and other wonderful, inspiring colleagues and friends along the way. Next slide. But really, I think the best way to summarize what an intern's experience like at NASA is that you will learn how to become a scientist. Today, I'm the principal investigator or team leader of a $2.5 million initiative to develop perovskite solar cells for space. I happen to have my own lab within which I mentor interns and postdocs that conduct meaningful research with me. I hope that you guys will all apply and join us at NASA and help us to conduct impactful research. Thank you.
Fantastic, Lindsay. It was so nice to get to hear about your journey. Now we're going to turn it over. We've got a few minutes for questions for the panel. As a reminder for those who are joining us, please put your questions in the chat box to the bottom right-hand side of the screen. And if you'd like your question directed to a particular panelist, please be sure to note that. This first question is for Vanessa. Vanessa, what can a student do to set themselves apart from the crowd, especially if they haven't reached some of the later courses in the university's CSE program yet? And what kind of passion projects could a student work on to improve their chances at getting a co-op at NASA?
Okay, so I'm guessing that they are talking about what can you do in terms of your completing your application and also experience, is that correct, prior to an internship or prior to work?
I am reading that as prior to an internship or co-op. What can a student do while they're still here studying to help their application stand out?
In terms of your application, I would say that think about what it is that what kind of experience you really want, what kind of work do you really want to do, and focus your application on that. Having 15 opportunities that you can apply to, sometimes students get a little bit overwhelmed because they're just looking at everything that's being offered across the agency, and they lose focus on what it is that they really want to do. Your internship is a time, though, that you can look at a variety of things to do. This is when you're learning, what it is you like and what you don't like. That's just as important. And so give yourself an opportunity to explore what you want to do before you complete your resume, and also before you complete the application. In terms of making yourself competitive in your application, make sure that you speak to all of your leadership opportunities, whether they are in STEM or not. Make sure that you can tell your story, who you are, what your goals are, what's important to you, how well you work with others, that sort of thing. and then participate in as many science and engineering challenges as you have time for, because that shows so much about your leadership and your goals and the things that you are capable of doing, and that you are easy to teach and that you have experiences to share.
Fantastic advice there. Lindsay, as somebody who's gone through this, this internship co-op process, what advice would you share with our students?
Absolutely. So I would say when you're crafting your application, it can be really useful to touch on some of your unique skills, like the skills that you have learned in lab and from your hands-on research. If you've done some independent research with a professor, that would be really beneficial to mention. Any opportunity that you've had hands-on, and it doesn't have to be directly engineering or course related. Perhaps you're on, a club or a team, something else. Maybe you build stages for, you do crew for theater. Like those types of things can have some translation. So mention all of your activities and anything that's even remotely related.
Fantastic advice. Yeah, at the University of Toledo, our students have some incredible opportunities to get engaged both in and outside of the classroom. So put all your skill sets on there. This is your opportunity. Don't be humble.
Absolutely.
All right, we've got a question for Dr. Kaminsky. We're interested in the Watts on the Moon challenge. Can you talk to us a little bit more about that and when you expect it to start?
Sure. So the Watts on the Moon challenge is our challenge focused on developing on the challenge, and we're really targeting the end of September. Don't get the date yet because we are still narrowing and then finalizing a few things to get to it. But watch for it in the end of September.
Fantastic. We're getting a lot of great questions here from students. I'll throw this one out to any one of our panelists. Does NASA accept international students? Is there an opportunity for international students to participate in either internships or co-ops? Vanessa, are you still on with us?
Yes, NASA does have a program for international students. I'm sorry, I'm drawing a blank on the name of it, and the countries has to be an agreement between the countries, but I think there are 15 countries right now that have signed the agreement, and we get something like 50 or so international internships and aims each year.
Fantastic. Thank you, Dr. Partridge. We appreciate you chiming in there. All right, we've got some additional questions here from a student. How early should I start with the application process if I'm looking for an internship in spring of 2021?
Okay, in spring of 2021, we are actually accepting applications now. And so I believe the final date for applicants is November 1st. So, get your application in as early as possible. Mentors begin looking at applications early. They don't necessarily wait until the final day for applications. So this is the time.
Great. It sounds like you need to get to work here. Procrastination is not something you want to take care of here. All right, now we've got a question from a student who is a computer science major. He's interested in what computer science internship opportunities might be available specifically at the Glenn Research Center next summer, 2021.
That's a difficult question to answer because for every session, there are different needs from the various projects. And so it really depends on what the mentors and project managers are looking for at that time. So my suggestion is that once you make an application, that you continue to look at what opportunities are available at the website. So once your application is completed, you can see all of the opportunities across the agency that are available.
Great, thank you.
I'd also like to make another suggestion. If you look at the opportunities for the fall and the spring, you'll see people who are working in an area that you're interested in, and you can always contact the PI and tell them that you're interested in an internship in the summer. Now, you still have to go through the application process, but you can start thinking about what it is you're interested in and make that contact and show the initiative, and that might be very helpful.
Fantastic, thank you. And to the student who had asked about the international student internship opportunities, you'll notice that Vanessa was kind enough to put the link directly in the chat box for you. So I encourage you to check in there. All right, well, we're almost out of time, but I do want to ask, this is a question for any or all of our panelists, but what one piece of advice would you give to our students who have an interest in pursuing either an internship or a co-op opportunity? What's the one piece of advice you'd like to leave our students with?
I would like to let them know that, don't stop. If you are not accepted for one session, just keep applying, because you never know what might happen. And if you don't apply, you know for sure that you won't get your foot in the door at NASA.
Fantastic.
Yes, I would like to advise that you have a growth mindset. So as you're looking for these calls for internships, be aware that you're not going to necessarily understand every word in the call or know how to do everything that you will have to do during your internship, but it's a learning experience and you're going to learn and grow. And that's the point. So don't shy away if it's something that you're weak at. Also realize that perhaps one course was really hard for you in class, but doing it in the lab is completely different. And that really might be your time to shine and grasp those concepts.
Great. Harry or Amy, any remaining advice for our students?
Yeah, I think it's important that you look for something that you're interested in. And if you're interested in it, keep trying. I think that's really good advice. Depending upon your level, the mentor is very important. So make sure that you choose somebody that you would be interested in working with, because it's really important for your growth and your expanding your opportunities.
And I would add to that, in addition to what you're interested in, think broadly as possible. You may find things, you may say, no, this is what I want. Don't rule out other possibilities. What you'll find with a NASA internship is that you'll end up being introduced to so many people, and you'll learn so much more than just about your single project. So think of this as one foot in the door, one way to get exposure to a whole range of opportunities.
Fantastic. Well, thank you all so much for sharing your time and your experiences with our students. We really appreciate you sharing your insights. Our next panel discussion is going to focus on opportunities to develop, use, and share technology. Our panelists include Ms. Janelle Steele, the Deputy Program Executive for NASA SBIR STTR program, and for Mr. Harvey Chavez is the Chief Technology Transfer Office at NASA's Glenn Research Center. Janelle.
So I'll do a mic check.
We can, thank you.
Excellent. So we're rounding third this afternoon, and hopefully Harvey and I can offer some insights that you can carry with you after this final panel of the day. It's great to support Consider GRC, my first home center, and now NASA headquarters is my second home center. But I'm also a MAC conference alum, having gone to Ohio University back in the day, and my two college-age sons also attend MAC schools, so the MAC universities are near and dear to my heart. Today, my goal will be to give you a brief overview of NASA's SBIR and STTR program, and then take as many questions as possible that you might have at the end. So next slide. Our program is not unlike what you might see from SBIR and STTR programs from other government agencies, and that we all have a mission and vision that complements our agency goals. As NASA strive to empower small businesses by creating opportunities that benefit NASA, the commercial aerospace industry, and the nation as a whole. We create these opportunities with our annual solicitation, which outlines the technologies and innovations we need to help support NASA's missions, but also have significant potential for the small business to commercialize the technology that results. Our next solicitation is scheduled to open this fall, November the 9th, so please mark that date. This is an accelerated release of the invitation for 2021 because we want to give firms an opportunity to receive phase 1 funding sooner than our typical January release is done. And I guess I'll turn on my video now so you guys can see me. I forgot to do that part. Next slide. Our program is actually tied to everything that NASA does, including human exploration, space technology, science and aeronautics, as well as our Artemis and Moon to Mars programs. We've invested in small businesses and research institutes in all 50 states, including Puerto Rico, and we do so throughout the year. As Congressman Capter mentioned this morning, we just announced our 2020 Phase 1 SBIR and STTR solicitation selections, and are extremely proud to have supported $51 million to 312 small businesses, of which 100 of those were first-time recipients, and 27% of those small businesses were from unrepresented groups, including minority and women-owned businesses. Next slide. I want to talk a little bit more specifically about the STTR program because in contrast to the SBIR program, it requires that small businesses partner with a research institute in order to propose. So while there are 11 agencies that have SBIR programs, there are only 5 agencies that have STTR programs, and that's us, the Department of Defense, the Department of Energy, the Department of Health and Human Services, and the National Science Foundation. Some of the benefits of the small businesses to pursue STTRs include the ability to leverage the vast knowledge at the universities, access to some of the nation's state-of-the-art facilities that reside at those universities, access to the bright minds that come out of the universities as potential talent for small businesses, and national recognition and visibility into technical areas of value to the nation. Some of the value for the RIs are opportunities to inspire entrepreneurship. We recognize that small businesses are the home to almost half of the national workforce. Access to funding for your research as well as for your IP, and the opportunity to generate publications and visibility in areas of importance to your university. Next slide. Our program, as well as all the SBIR and STTR programs across the agency, is defined by 3 phases. Phase 1, or the idea phase, is where the merit and feasibility of your solution or your technology is developed. Phase 2 is then focused on the actual development, demonstration, and delivery of that innovation. And then phase 3, which is non-SBIR funded, is when the innovation technologies, products and services make their way into NASA missions and the commercial marketplace. The differences in our agency programs, and is why it's very important to pay attention to those nuances, is with the funding levels, the period of performance, and the various support programs that we offer. For NASA, our phase 1 is $125K for 6 months, but for STTR, it's $125K for 13 months. Offer phase 1 awardees the opportunity to opt in for the Innovation Core, or I-Core program. This is a program that we offer in partnership with NSF, who's been running I-Core since 2011. And it trains the small businesses to understand how to approach discovering customer needs, which is going to be vitally important in transitioning your technology beyond phase 2. Both our SBIR and STTR phase 2 awards are $750K for 24 months. But we also offer post-phase 2 awards to support a company's journey to commercialization. Next slide. Both Dr. Breitstein and Dr. Perez-Davis talked about great successes that the agency has had in collaborating with commercial partners, small and large. Our program contribute to these successes. And one story I wanted to highlight is a partnership with Glenn Research Center and DNA Medicine Institute, also known as DMI. With SBIR funding, DMI developed a system for astronauts to check health on long missions to outer space. DMI reusable handheld electrolytes and lab technology for humans, or R-Health, is a system that can generate comprehensive medical test results within minutes using a single drop of blood. The technology is easy to use and enables astronauts to address medical issues immediately without waiting for guidance from mission control. DMI's success with R-Health earned the Institute $525,000 grand prize winner of the Nokia X Challenge. They've gotten several $1 million in funding from private investors and multiple biotech and pharmaceutical partnerships. And this is just one example of how our program stimulates innovation and growth among small businesses while also addressing NASA's needs. Next slide. So in closing, I know this presentation was quick and it might have generated more questions than we may have time to answer. So I wanted to point you to our website, which is sbir.nasa.gov. It's a great place to start to explore our program, and it hosts a great deal of information about it. We also have our help desk, which can help find questions or lead you in the right direction for answers that may not be on our website. You can also hear from some of our other program representatives at other virtual events like this. I know, for instance, the SBA is hosting a virtual SBIR week across the nation over the next several months. But most importantly, please save the date for our upcoming Innovation and Opportunity Conference, which will be held October the 20th through 26th in a virtual manner, of course. We'll have more information about that on our website. Thank you, and I'll pass it to Harvey.
Thanks, Janelle. I really do appreciate the opportunity to, I guess, be the almost final speaker here today. And hope you've enjoyed the day, hope you've learned a lot, and hope you will continue to have a positive opinion of us and look for opportunities to partner with us as well. Can I get the next chart, please? So I'm going to talk about the overall tech transfer program here at Glenn, as well as the agency, and include some unique opportunities to partner with you all and have you partner with us. This chart is a little bit of an eye chart, but it's an opportunity for you to see that throughout NASA's history, tech transfer, the opportunity to commercialize NASA and federal technology, has been a big focus of Congress and of the agency. Going back to the early 80s with the important legislation of the Stevenson-Wilder Technology Innovation Act and the very important Bayh-Dole Act, which allows you as our partner to retain ownership and, for instance, especially for the universities and small businesses, to obtain title to inventions that would be jointly developed. Most recently, in this, I guess, the last decade, there's been some lots of activity and encouragement by the administrations, previous administration as well as the present administration, to really aggressively have our technology transferred to the industry for its commercialization, and as it says on our byline, for the benefit of all. Can I get to the next chart, please? Okay, so NASA has a very broad and expansive patent portfolio, which is organized for all NASA centers across the 15 iconic elements that you'll see on the right side of this screen. So what we did several years ago was look at all of our technologies and try to organize them to allow people to search for them easier and more efficiently, and thus allow not you necessarily to look for a technology from a particular center, but really look for technologies that are key to the industry or to the area of focus that you're most interested in. One of the interesting things about this is then the icons that you'll see there on the right allow you to kind of search, but it also gives you then access to numerous different patents in different areas that are either patent or patent pending that would be available for commercial opportunities for you to possibly license. Can I get to the next chart, please? So what you see here in this chart is the Glenn version of this program. We have over 200 patented and patent pending technologies. You'll see that a lot of our technologies are focused in our core competency area that was referred to earlier by our Center Director, Marla Perez Davis, is really in our fundamental area of high strength and high temperature materials and coatings. And that then leads to a tremendous amount of focus in lots of other areas that you see. We have a lot of focus on the communications and sensors area, some of our more active areas for licensing, as well as lots of areas across our other core competencies of power generation and storage, in aeronautics and propulsion, as you'll see in the top left side. So they're all available. You know, come and visit, come and ask about us, and we'd be more than willing to share them with you. Next chart, please. And focused on the startup industry, as the charts transition. Here we go. Focus on the startup industry, which I assume possibly many of you are, not knowing who's out there. I'm talking to the blank screen here. But the startup initiative allows you to obtain access and rights, intellectual property rights, to our NASA technology. Literally, as it says there in the bottom left, hold on to your money, get a head start. Because what this gives you is the opportunity is for no money out front, for assign a very easy to apply for license through our automated system called Atlas, which I'll talk about shortly. But you get a very standard license agreement, which I believe, and many people have shared with us before, has very generous terms and generous accommodations for your ability to then take that technology, develop that into a commercialization opportunity for your company. Those licenses do come with a little bit of NASA inventor time, but it's really easy. As you can see there in the bottom right, you go to the Atlas system and you put in some key information that generates an opportunity for us to kind of contact you and then follow up with you with a very streamlined licensing process system. Really from start to finish, it should take us under, I would say 4 to 6 weeks tops on a complicated issue, and probably even less on a simple issue. We've done some licenses from start to finish literally in 24 hours. So the options are there. You know, I encourage you to, as I said earlier in the chart, to look through our patent portfolio. And if you're a startup, it's easy because it's literally no money upfront. Next one, please. Software is another generous opportunity, and you'll see there that, again, it's organized across 15 iconic areas. It's a little bit different than the patent portfolio. But the best thing about NASA software is, you got it, it's totally free. You find a piece of software that you'd like in our very expensive software catalog with literally thousands of different NASA codes that have been developed for our use that we'd now like to share with the public. And you fill out a simple application, and within hours, literally, you can be given a key to download the software and to use it. These are all executable software programs, and it's an opportunity for you to use that software to help your company do with it as you see fit. We generally do not patent our software. In rare cases, we do, but by and large, these are all publicly available softwares that can aid lots of different companies in lots of different areas and lots of different applications. Next chart, please. So here we go. Like in addition to the licensing software we talked about earlier and the licensing of technologies, we also let go of many of NASA technologies, and those are just available for your public domain usage and application to your particular business areas. These are things that we may have just no longer pay the maintenance fee on a patent, for instance, or we feel that the commercialization of this opportunity is probably not as maybe in line with what we're trying to do, and we therefore give them to you as public domain opportunities. Hey, as they say, you paid for them so you can have them, and then we continue to help you throughout the process to possibly take those technologies, apply it to your situation, and run with it and for successful business opportunities. Switching channels a little bit, if I could go to the next chart, is a really unique opportunity here, and I think that possibly many of the attendees here today might be interested in. It's the Technology Transfer University, T2U, where they're really bringing real world, as it says in that top bullet, real world NASA-proven technologies into the classroom. It gives you an opportunity to assess our technologies, develop a business plan, et cetera, and with your own capabilities or a team of unique individuals, then receive access to the NASA scientists and innovators, literally, as they say, giving them a unique look into our details of our technology that we're working on. Then you can develop that little group of people, as we're doing now, for instance, through an initiative called FedTech, which is looking at trying to, with a group of entrepreneurs, commercialize our technology, take those technologies and possibly license them through a consortium of a collection of individuals that you did together through the T2U. And then we would be more than willing and interested and happy to establish that kind of an opportunity with our University of Toledo friends. I might mention that, like Marla Perez-Davis, I too have a degree from the University of Toledo, my master's degree in engineering, and some 35 plus years ago. So I have a very fond memory of the university, and I'm glad we could kind of have this event here today. Moving on to an example of our commercial success, if I could go to the next chart, is this whole thrust of commercialization. This is a really unique situation that's evolved over the last, I would say, 12 to 24 months, that we have, and this is kind of an innovation opportunity, that we're really basically developing a consortium of numerous US companies to improve the state of the technology development and technology state of art of the US space industry with some of our unique NASA Glenn Hall effect electric propulsion systems. We've had numerous licenses over the last several months, and I can't necessarily share with you all those names right now, but the interesting opportunity with these is we don't just have a license, we also have a partnership agreement in the context of something called a Space Act agreement, which I'm going to talk a little bit about more in a few charts, but there we're able to marry up a license with a, so to speak, a support partnership development agreement in something called a Space Act. And we've had numerous interests of companies interested in doing it. Literally as fast as the applications come in for these, we just turn them out and send them on out to the companies for their usage. And we've had a tremendous amount of success and a lot of interested people trying to help the US space propulsion technology really move forward in all of its, in a really nice and unique initiative. Another example, if I could go to the next chart, was referred to by both Marla Perez-Davis, our Center Director, as well as our Administrator, Jim Bridenstine. And here, I'd like to kind of focus on a little type of different kind of take on this one. So this is a repeat customer for us. We helped the company, EP&R a couple of years ago, refine their technology so they could sterilize the inside of ambulances. And obviously, unfortunately, with the situation we're dealing now with the pandemic, the company saw a unique opportunity to improve their product and enhance their product's capability and the breadth of usage. So we continued that. We re-partnered with the company through a new Space Act agreement and are helping them do some testing and development and an opportunity to kind of further the commercialization and the broad usage of their equipment. As our administrator referred to earlier, there's an opportunity possibly clean some of our own NASA satellites by applying this technology and trying to use our partnerships with these unique and small companies in a special and unique way. Next chart, please. So what can NASA Glenn, as all NASA centers, do for you in terms of our partnerships? We have intellectual property, like I mentioned earlier, throughout of our very broad patent portfolio, as well as the software catalog. We also have unique test facilities, and we're willing and able to partner with you to have you use those facilities. That's usually done on a reimbursable basis, but I'll talk about that in the next chart or two. The next one is literally the opportunity to have our engineers help you because we have a tremendous amount of subject matter expertise. So you'll see in the bottom right corner, work with your company to help the company over a technical challenge that some of our very smart people and capable individuals might be able to advise you on. And then literally packaging it all together is the research development test and evaluation services, where we might want to test one of your sensors, your instrumentation, your product in some of our unique facilities with using some of our capable engineers to apply that and then help you to improve your product for its commercialization. So the idea is through these services is that, we had talked about earlier the technology transfer program where we're really trying to commercialize NASA technology. In this situation, we're really trying to help you with your products and your challenges improve the commercialization of your situation. I go to the next chart. I think this is almost it. That's the charts. There we go. So there's two different kind of Space Act agreements. So the Space Act languages gives us something called ability to entertain or engage with you as a partner in a unique partnership agreement. So it's not like a procurement, but it's similar to a procurement activity where either on the left side you pay for us to do it, or on the right side where we have a desire to put in some of our own time, money, and energy and expertise and collaborate with you on the partner. On the left side, the idea is that you would pay the full cost for that effort if you want to use one of our unique facilities. Numerous people come in, for instance, to use our IC research tunnel and some of our other propulsion devices or some of our space vacuum chambers, SpaceX, for instance, or not necessarily done through a space vac, but a similar thing. But where numerous companies come to use our really world-class facilities. Can't interfere with our mission work because that obviously would take priority over any sort of a reimbursable activity. And then on both the SAAs, whether it be reimbursable or non-reimbursable, the inventions resulting from the SAA, if they're jointly developed, remain with you as the inventing party. If we were the inventor, it would stay with us. If you're the inventor, it stays with you. And on the right side, each party pays their own costs, where it's something we wish to benefit in terms, and you wish to benefit, the idea of a mutual beneficial relationship. And then results must be shared by the parties. It has to be not just retained for you as an individual, but it would be shared with potentially other industry members or other research organizations. And the idea is that those results would be published widely because the government is putting money into it as we share many of our results for many of our activities and without further restriction. I think that's all I got. I think the next chart just has a pretty meatball on it. And with that, we pretty much are hopefully opportunity for questions and answers here between Janelle and I and maybe some of our other people who might wish to help us out here as we try to let you go out and have a beer. I'll definitely go have a beer. Sorry.
Thank you, Harvey and Vanessa, for your great presentations. If you have questions for our panelists, please put those in the chat box in the bottom right-hand corner of the screen. As you're doing that, I thought it was a fun fact for those of you who are tuning in. We've actually had almost 350 participants tuning in throughout the day. So this has been a fantastic day with lots of information. So we've got a couple of questions coming in. Let's start with this one. It's not directed at either panelist in particular, so I will defer to you guys. But what would you say is the biggest program challenge that NASA currently has that would be an opportunity for those in attendance?
Ladies, Janelle first, would you like to?
Sure. So as we talked about a little bit, and you heard a common thread through most of all the presentations that went on today, is that we are trying to go forward to the moon and on to Mars from there. And there's several technologies that are supporting that effort. Amy talked about some of the power technologies that she is looking for in her what's next, I think it was, Amy. I'm not sure if I'm saying that one right, but Prizes and Challenges has efforts. So that's where our focus is. That's where our funding is going to come in right now. And there are a lot of opportunities for small businesses. There's a lot of opportunities for those who are looking for internships in those areas to support.
And I would just add that our challenges is just that fact that so many of our technologies that we've developed for NASA's usage and NASA's applications to many of our mission activities are really just stuck, if you will, in early stage development. They require, for the purposes of commercialization, more development activity and more, which usually takes capital and time and patience. And so that opportunity exists to many of you out there. but it just takes time, energy, and effort. And we have very few products that you could just, so to speak, say, okay, can I buy this and then apply it to my application? Yes, you can, but the point is, it still needs development and opportunities to further mature its technology readiness level.
Fantastic, thank you. Harvey, this next question's for you. How can we use the Glenn Research Center's wind tunnel for the university's research?
So we have unique relationships with our, university partners. We'd enter into some sort of a Space Act agreement. The idea being is that it would be a very mutually beneficial situation where we interact with our, educational institutions, so to allow students to possibly use some of our facilities as part of their educational pursuits, or along those lines. And so you just have to kind of contact our office, and our contact information will be provided as part of the follow-up to this event, for you to kind of reach out to us and see what we might be able to help you in terms of time and energy and effort. Please note, though, that in these days of our dealing with the pandemic, many of our facilities, actually probably most of our facilities, still remain closed for personal safety, and as many of us and as many of you haven't been back to the office since those fateful days in March. And so right now there's a huge backlog of mission-related work that's waiting to be tested out in some of our facilities. And so there'll be a little bit of a waiting line, but like in all good amusement parks, it's worth usually the wait, whether how long the line may be. The longer the line, usually the better the ride.
Fantastic, thank you. Janelle, this question is for you. Is it recommended or required for startups to participate in an I-Core program before submitting an SBIR STTR proposal?
Good question. No, it is not required to have participated prior to. We offer in our program, when you propose, the option to opt in to the I-Core program. So once you are selected for a Phase 1 award, you are again asked if you still want to be a part of the I-Core program. And that's when you can really make your final decision. We highly encourage that participation, again, because it is such a great opportunity. Companies do not get a chance to really do the deep dive into customer discovery that is sometimes necessary to understand really where your technology that you're looking to develop might have application. NASA certainly is a customer, but we always want to make sure that there's a commercial market for you also. So this customer discovery is really a good opportunity to take advantage of when you're going through the Phase 1, because it positions your Phase 2 proposal a lot more specifically, and certainly gives you options beyond Phase 2 to find places for infusion or commercialization.
Fantastic, thank you so much. This question isn't directed to anyone in particular, but Harvey, since you mentioned the fateful days in March when COVID-19 started to really have a global impact on our lives, can you talk to us about the impacts to potential open opportunities or partnerships that COVID may have had or will have with NASA in the future?
Sure. In terms of our tech transfer activities, I actually think that many of our tech transfer partners, if you will, or our commercialization opportunities really have increased. And that's a really nice opportunity, as there's many companies out there really maybe with a little bit more time on their hands trying to see how they might benefit from some of the federal technology and some of the really cool stuff that we have to offer. But in terms of the partnerships, we've had our challenges. I'll be honest that we've gone through a very disciplined and very careful exercise where we evaluate each of the agreements to see what work can be done in the telework environment that we're presently operating in, and what work really requires on-site access. As hopefully the pandemic begins to recede and the effects of that are, shall we say, reduce and are minimized, there'll be opportunities for more of our researchers and engineers to go into the facility to possibly, run some tests or go into their labs. I know Marla Perez-Davis is entertaining letting a researcher in periodically on a day here, a day there. So the opportunity, maybe if you go in for a day to your lab and to your facility, you might be able to then continue teleworking easier with great efficiency and effectiveness for the next couple of weeks. But I will say that the pandemic has impacted a lot of our customers. I mean, they're definitely interested. As I said, the line is not getting any shorter of people interested in using our facilities, as well as access to some of our great computational activities as well. But the good news is, on the other side, though, we were able to continue numerous activities and really enhance lots of opportunities, as we're not, so to speak, distracted by the testing or application in our own labs to help many of our partners effectively during this time period.
Great, thank you so much. Janelle, this one is for you. Is there collaboration with the SBIR opportunities from the armed forces?
So, great question. As I mentioned, there are 11 agencies that participate in SBIR. Department of Defense is by far the largest. All of their different divisions of the Army, the Navy, the Air Force, Missile Defense Agency, all participate in the program. So you will find that of those 11 agencies, there are several technologies that we all are looking for, very similar technologies. The beauty of the SBIR program is that you can take your one proposal and you can provide it and submit it to all agencies that are looking for that type of technology. You cannot accept an award for that same proposal to several different agencies, but you certainly can shop it around and determine who is ready to bite and has the greatest need. So not just the Department of Defense, which again is the big fish in the ocean, but there are several other. We often find some connection with us and the Department of Energy. We sometimes find connection with what we're doing in Health and Human Services. So there's a lot of overlaps, a lot of opportunities for folks to look beyond just that one agency to several different agencies for their technology, and I encourage you to do so.
Great, thank you so much. As we're starting to wrap up, today has been incredible. We've learned so much about collaborative opportunities and grant funded opportunities for our participants. What's the one piece of advice that Janelle you would like to leave the group with?
Sure. If you're looking at starting to participate, and particularly in our program, and I like our program, of course, because it's near and dear to my heart, but because it does cover the whole waterfront of technology needs that the agency has. Go to our website, look at the past solicitation. You'll see a lot of our technologies laid out there from all the mission directorates. And the beauty of it is that our solicitation probably stays the same. About 85 to maybe even 90% of it might stay the same from year to year. And so you can use that past solicitation to kind of key in on a particular area of interest for you. It's going to have a lead center listed for the subtopic, and we have plenty of points of contact that you can contact to get some more information, not only on the technology that was called out for the solicitation, but the broader breadth of technology that we're doing in that particular technology area. So our program kind of can serve as an opportunity to understand the various technology areas that the agency is interested in, and then key you into a person who can talk to you about the various opportunities that are available in that area.
Thank you so much. Harvey, as a Toledo alum and now with NASA, what is the one piece of advice that you want to leave our participants with today?
Wow, that's an interesting opportunity. But I listen, as our administrator started off earlier, we do a lot of cool stuff at NASA. We do a lot of interesting things, and it's an opportunity, as many of our speakers have shared with you today, to be involved in really cutting edge, really neat and interesting opportunities. My biggest piece of advice would be, stick with your education, stick with your opportunity to work with others. Think out of the box, think big. Don't be encumbered by traditional thinking, and be challenged by the opportunity to do something new and exciting each and every day. Whether it be, who would have dreamed that several months ago we were in this situation? But you think about all the innovations that have been already created in this, during even this situation of the pandemic. It's amazing when you can apply your abilities to help to so many different areas. And I just encourage people to kind of think out of the box, think big, and go pursue your dreams, as I did with mine many decades ago.
Great advice. So reach for the moon, or Mars as it may be. This has been a fantastic day learning about all the collaborative opportunities that are available. I want to wrap up today by turning the program over to Miss Mary Lobo. She is the Director of the Technology Incubation and Innovation Office at NASA Glenn's Research Center. I'll turn it over to you.
Yes, thank you. I have the pleasure of providing the concluding remarks to this wonderfully informative event today. Even as a NASA employee, I always appreciate the opportunity to hear from our local and agency leaders about the overarching objectives that NASA has, and combine that with the programmatic leaders who share the details on how we collaborate to make those objectives happen. And so hopefully you've gotten that out of this event today as well. So on behalf of our Center Director, Dr. Marla Perez-Davis, and the Glenn Research Center team, I'd like to thank the University of Toledo leaders and staff for hosting this event, with special thanks to Dr. Adrienne King as our moderator today. Thank you to Congresswoman Marcy Kaptur, NASA's Administrator Jim Bridenstine, Associate Administrator for NASA's Space Technology Mission Directorate, Jim Reuter, and all the panelists for your support and sharing of information with today's attendees. For all registered attendees, at the conclusion of this WebEx, you will receive a post-event message, which includes a brief survey to capture your thoughts about the event and potential future engagement. We ask that you complete the survey to inform us on what you'd like us to share with you and the types of opportunities that you may find most beneficial. For unanswered questions that were posted in any of the Q&A sessions, we will be posting those responses. And the entire program has been recorded and will be available next week via the link provided on the university website. Please don't forget to tune into Ignite the Night Ohio. This virtual iTech event will be held today from 3 to 5 p.m. as entrepreneurs present technologies that solve real-world problems and potentially some of NASA's largest challenges. Specific focus areas include quantum sensors, synthetic biology, small spacecraft technology, advancements in mining, and X-Factor innovation. Join us today at nasaitech.org, and that address is listed in the chat box. Thank you so much and have a great afternoon.